Same recording in progress.
Okay, you can pause that if you want.
Out collision alignments. And we good there, Ron?
I started the recording. I just don't have you in full screen. I don't know why. Does it? Do the rest of the attendees, can you see him in full screen? You can put yes in the chat.
What's happening?
He can't see full screen.
You can't see what?
Is that better?
It could be on
He's
my
only
end.
seeing the camera right now. He's
Yeah.
seeing you guys, I hope.
Okay.
Camera, yes.
Yeah, he just
Yeah.
says it can't make.
Tell me
Can't
to
make it
switch
full
to your
screen.
PowerPoint. Say PowerPoint because you don't have Flickr if you need.
Okay.
Because
Okay.
I have your PowerPoint.
Okay.
You'll get it when I send it to
And
you.
you're going to put it up here.
Okay.
Tell me when.
Okay. Perfect. All right. So is everybody able to see us so we can get a thumbs up in the comments? There is, I believe you have comments turned on there, Ron, right? So that we can actually, if people have any questions, that sort of thing, nobody's muted, correct? Or they're not required to be removed?
They're muted. They could unmute if they want or go in chat. It's up to you.
Are we able to up his volume so we
Perfect.
can hear him?
But yeah, let me see if we can up that one a little bit. So I am losing control of my mouse. Sorry, guys, we got a little technical difficulties here trying to make this right for everybody. All right, I think I'm maxed out there, so we're gonna have to work through that.
We'll work on that.
So. Great. So, Greg, if you want to jump into the presentation. So we first wanted to start out by thanking all the sponsors of PAVE, putting all of this together. So as you can see on the screen, there's a whole number of companies that have provided an opportunity for this training, as well as all of these events are going to be recorded. So if you want to revert back to it at some point, you can do that for the next 30 days. So, all right.
I'm trying to close.
Hang on. Still working through some technical difficulties here a little bit. Oh, no. Yeah, that's not on my screen. That's on the meeting itself. All right. So let's jump right into collision alignments and having some conversation with that. So, Greg, are we on both screens? Oh.
Hey, Ron, how many people do we have here with us today? Are we able to see faces? Is everybody just no cameras turned on or anything like that?
See, it should
I guess they don't have their cameras turned on.
full screening as Teams.
Okay.
If he goes to not full screening.
Okay,
Teams.
no problem. Well, first off, we do want to thank everybody, for taking a few minutes on a Saturday morning, a couple hours here to try to make sense of some things. Your shop and the things that you're doing there currently, we don't know exactly, and I'd be kind of curious to hear, are these people, are you who are here with us, how are you actively doing alignment work already, or is it something that you're still just kind of exploring in your shop? Do you know thoughts on that, Ron?
I'm not sure. They could just click the unmute and answer you.
Okay, yeah, y'all are
Tim?
welcome, please.
Just unmute. There's only a couple guys on. We can work that
Yeah.
way.
Nope. We got some comments here. So I got a yes from Tim Rivers.
So that's a yes that he's doing alignment work and or yes that he can hear us, I hope. But say yes. Who knows? But yeah, we know it's a commitment on a Saturday morning to get away from the things that you normally like to be doing for your, your fun or family and all that kind of stuff. So thank you for taking a few minutes. I think the way that, we're going to approach it is trying to be a resource to you guys and help you understand the way we do come to the table, not only for the equipment and things like that, but for the training and types of things that you and your shop are going to, goodness knows, as an industry right now, that things are moving so fast. All of this ADAS technology moving on, let alone the technology on the cars, and they just keep kind of evolving. Hunter Engineering Company on a national level has a lot of people and resources in place to try to help make this a transition. And certainly for those of you who are still in an exploratory stage, maybe you haven't decided you wanted to do alignment work at your shop just yet, but you know that it can be frustrating subletting that stuff down the street because you can't control your schedule quite as well. You may be not able to control the quality and things like that involved in it. So we just want to help show you a little bit about what our equipment is capable of doing and how we come to the table as a resource to help you out.
Absolutely. So as we go through any questions, feel free to reach out, to put them in the chat. Take yourself off mute. We'd love to have any conversation with it. But let's jump into where collision alignment is. And, I'm kind of fortunate. I get to work with a lot of you all the way around the country. And there's typically two different ways that we see collision alignments going, either a shop has embraced it, brought it into their shop and is taking care of it right off the bat themselves, or it is a sublet function. They're utilizing the tire shop down the street, maybe another collision center or a dealership to be able to do that work. And we're going to touch on a few things for both those scenarios. But the other side of that is we want to encourage you as the industry changes and the way that collisions are changing. I think it's something that you might want to explore in the long run, making it as an additional service that you're adding to the shop. So Greg, if you want to jump over to the next. All right. So when we get into the world of suspensions, we have 4 different types of suspension. Of alignments that we're dealing with. So we have a maintenance alignment, which in a lot of the cases, when you're subletting your alignment out to a repair shop down the street, they're potentially giving you a maintenance alignment kind of thing. That's the tow and go alignment that we talk about on a regular basis. Then we have, and that's where we replace new tires. Maybe we put on some parts and we want to make sure that the car is pointed in the right direction afterwards. Then we have that symptom and corrective one, which is where our customers are coming in and saying, hey, my car is pulling to the left or pulling to the right. I have a vibration, those kind of things that are alignment related kind of situations. And then we have that performance one. I've raised my vehicle, I've lowered my vehicle, I've put a leveling kit on it. I've done some kind of customization process that has changed the way that the alignment is, or maybe I want it to handle a little bit better because I'm going to go take it to the SCCA racetrack for the weekend, and I want it to handle a little bit better in the corners. So all of those are different types of alignments, and the ones that we're going to focus on today is that collision alignment. And one of the big differences with a collision alignment over a regular traditional any one of the other 3 areas of alignment is the OEM is looking to have that car return back to that condition that it was prior to the accident. So they have a significant number of additional responsibilities that they're going to ask for the shop to do. So again, if you're doing it in-house or you're subletting, we want to make sure that we're communicating that with whoever's doing this work, that we're looking for all of that full detail. And I kind of go back to a group, and at one point I was down in North Carolina. I was down in your neck of the woods. I was with a group of managers, and I asked them all, hey, how many of you use repair plans or OEM procedures? And they all raised their hands, and I paused for a second, and then I said, for alignment. And when I said that, everybody's hand came down, and we determined that everybody is using an OEM procedure on how to weld on a panel or how to separate a quarter panel from a bed and all of those kind of things, but they're not doing it for collision alignment. And when we get into the collision alignment space, there is a number of different opportunities different processes that need to be taken place to make sure that that's happening. So you can see on the screen here, we got a bunch of different bullet points of the different things that we need to do in the collision space. On top of that, if we're really going to get heavy into the collision space or the collision alignments in your shop, you also want to make sure that you're maximizing everything that you can be doing and making sure that you're taking advantage of the equipment that maybe you have in the shop. So one of the things that we're going to touch on a little bit today is how do we supercharge our shop. Greg, I'm going to jump over here one. So as we were talking about that tow and go alignment, that's our quick and easy, down the road, we've got a basic maintenance on it. So, and that's typically this printout that's on the left side of the screen is our maintenance alignment printout. So it's got our basic camber caster tow, maybe total tow, some steer ahead. It'll give us our thrust angle, which is critically important in our ADAS space. But it will also, but it doesn't really give us all the information that we need. So what we're really looking for is to make sure that we have all of the data that we need. So in that, there is some basic angles, camber caster tow, that we're going to get into those, as well as we're going to get into some of the detail of the advanced angles that really help us identify, do we have a bent strut? Do we have a bent tie rod end? Do we have a bent control arm that's affecting the way that vehicle is on the road? So When we get into advanced alignments where we're talking about those primary angles and secondary angles, there's a diagnostic process through it. We want to make sure that we've got everything we need to have in the vehicle, that we have those primary angles, we have the secondary angles, we have the body measurements, and the light, and all of the other factors that can be in play. So the first part of that is grabbing information and making sure that we're gathering all of the right information and that we're translating that over to the alignment technician, both from the front end as well as that alignment technician knows what they're asking for. So that is one of the things that we do for that is we've put together a pre-alignment assessment. I believe that you guys all have this in your tools as a way to ask customers questions to understand what happened in their accident, to identify potentially, do we need to make sure that we're doing a pre-alignment assessment with this vehicle, or what other damages could be underlying that we're not necessarily seeing. So let's jump into those basic angles, and we'll talk a little bit about that, and then we'll start getting a little bit more into kind of the details of what I talked about earlier. So Justin, you want to share a little bit about what these angles look like for
Absolutely. Absolutely. So, and again, not knowing for sure the depth of your experience with current alignment work, we certainly don't mean to be redundant or sound like we're offending people, because sometimes in class, because we teach classes all over the country too, and you're going to have a group of students, and some people are going to be like, well, no, duh, everybody already knows that. We still like to make sure we've got a good foundation of truths associated with alignment work. And so when we understand our basic alignment angles, we're going to understand the things that are causing tire wear, the things that are causing a car to pull or drift one way or the other, once we have isolated what may be those non-alignment related things as well. So just a basic understanding of it real fast then. Camber, of course, and by the way, in this moment, is there a way they can see us differently? Can they see me? Do you know? How hard is that? Let's do that.
No, I can, yeah, now I can. Yeah, now we can see you. Yes.
Yeah. Okay, great. So what I'm talking about this is the idea of what are our wheels and tires doing going down the road, right? And like I said, camber is our first angle where we know we're getting things associated with pulling or drifting and or tire wear. And camber, of course, again, forgive me for the redundancy, but that's when our tires are leaning in from the top, leaning inward or outward for positive or negative camber. And, we see cars doing that on purpose sometimes where those tires are stanced in, something like this. And that is perfectly fine functionally if a person wants to. It's beating up the components a little bit. It's chewing up the tires a little bit. But that's where we see that camber really sticking out. Cross camber, of course, can cause us to have problems with straight line stability, right? So if they're both leaning in or both leaning out, that's great. They're going to cancel each other out. But it turns out a tire in motion when it's leaning over one way or the other is also trying to actually turn in that direction. That's what winds up causing that tire wear, is that friction between the tire wanting it to turn right and you wanting it to go straight. And of course, when we got tires that are not canceling each other out, maybe you've got one leaning over or both leaning over, something like that, you're going to have that pull or drift in those kinds of directions. And that's what we refer to as cross camber. Wonder, what are they doing compared to each other? Okay. The next angle we would talk about from that slide.
So before we come off of camber, I want a quick little tidbit when it comes to camber. So as we're talking about camber, especially in the collision space, there's times where cars are going to be coming into us where there may have been damage to that car. Maybe it's rear end damage, maybe it's one side or the other, and we've got negative camber on both front wheels. That's typically indicative of the fact that the car has settled down. So it may not be accident related damages, or it may not be accident related items. But when we change that ride height, especially in the front, and angle it down, as we get through our repair process and we start doing let's say our calibration for our front cameras, if our car has settled down 1/4 of an inch in the front of it, our camera that's now looking 200 yards out in front of us, instead of it looking through the middle of the lane, starts looking at the road in front of it. Instead of seeing that there's a pedestrian walking out in front of it at 200 yards, it's only seeing asphalt at 100 yards because of that settling. So the other side of that is, in the collision center side, when we go to do a calibration and it keeps failing, that may be that we didn't actually get the alignment right in the beginning, and that the ride heights are not right and consistent with it. And we're utilizing the alignment system to be able to tell us because we have two negative cambers that are equal negative cambering, that's identifying the fact that our car has settled in the front end.
Mhm.
So
Yeah. So next thing we talk about will be caster. And caster is one of the most widely misunderstood angles in our alignment work. It's really funny teaching the class. It's entertaining, let me say that. Entertaining, kind of listen to people describe caster based on things that have been handed down to them by technicians from over the years, and their grandpa told them this thing, they saw a poster once. And it's kind of wildly misunderstood, which is challenging when you think about the fact that it's one of our most important straight line stability angles. And it kind of gets overlooked. Now, there's a lot of vehicles where caster is not even adjustable from the factory. And in the collision world, that really puts you in a spot where you need to make sure you know exactly what's going on with it, right? But caster as an angle is what we refer to as the position of our steering axis, which is created, I don't know, in certain places, you can see the vehicle here. Our steering axis is created by our pivot points, is really what it comes down to, right? So in this case, I've got more than likely, I've got an upper strut buried up here. I've got a lower ball joint at the bottom. Those two pivot points, if we drew a line between them, we call that our steering axis. And where that steering axis, how far it's leaning back or forward compared to a vertical line, is the actual measurement of what caster is. So you'll normally see that in some kind of a 3 to 6 kind of a range for most passenger vehicles. Right. So caster, a very misunderstood but highly important angle in terms of straight line stability and returnability and even cornering on these vehicles.
and as we get further into those secondary measurements, caster becomes our diagnostic angle. That allows us to be able to diagnose what's bent, what's damaged by utilizing a lot of those caster numbers. So it becomes very critical in the process.
Yeah. So then toe, and I usually describe toe as coming in 2 different flavors, where we have individual toe and total toe. Now, individual toe is just wherever on Earth one tire is pointing, all by itself, compared to some kind of a reference line. Now, at the rear of the vehicle, we're going to have a different reference line than the front, but either way, when we are towed out, it is a negative number, and when we're towed in, it's a positive number. So as an individual tire, whatever it's doing, whether it's green or red, just indicates where it's pointing. Total toe, by contrast, is what on earth are these 2 tires doing compared to each other? The objective for cars, turns out, going down the interstate at 70 miles an hour, is for those tires all to be pointing in the exact same direction, not towed in, not towed out. And some of these systems have a little bit of flex built into them. So when you look at your specifications for vehicles, your total toe number is probably going to be a little bit positive. Towed in just a hair, maybe towed out just a hair, because in motion, those are going to flex based on the rubber and steel part of our suspension and steering components. They're going to flex back into that 0 position is, again, what we want when we've done a good alignment.
Yep, and the other side of that is, if any of you have done BMW alignments, they typically will ask you to put weight bags in the cars. And we're really, instead, where a lot of people think that's simulating like people sitting in the car, it's actually simulating the dynamic air pressure of that car traveling down the highway. So that pressure that's pushing down, which means that all of our suspension is kind of flexing and tightening up, which then takes our let's say our negative camber and pulls it back in to get it straight and aligned. So in those specs that we're aligning a car static sitting on the rack, we're actually building it in so that as it's traveling down the road and the air pressure and the aerodynamics are pushing the car down to the road, that our wheels are actually getting exactly where they need to be at that time.
And this is a good time just to point out this thought for you. If you are currently doing alignment work, it is not unheard of to have people ignoring putting the weights in these vehicles when they call for it. And sometimes people are like, you know what, those German manufacturers, they just think they're better than everybody else. They want us to do that because they're cooler or whatever. And I want you to know it really is not that at all. The specifications for that vehicle are only right when that weight is in the vehicle. And so similarly, if I took a Mustang and I put a bunch of weight, if I put 500 pounds in a Ford Mustang and aligned it to the factory specifications, then it's not going to be right when the humans are in it. And so be very intentional about that. I know that's a challenge that a lot of us are facing. Certainly you guys in the collision world are seeing more of these new Toyotas and the new Toyota trucks, the larger and the smaller chassis frame, all of those are requiring some very specific load leveling and ride height measurements and stuff taken just to pick out the correct specifications before we even begin to attempt that alignment. And so weight's a thing. If you don't have good weights in your shop to be weighting on these vehicles, I want you to look into that. I think a lot of folks are looking at options like plastic coated free weights or something like that. So we're not accidentally spilling out a bag of sand into the back of somebody's $100,000 Sequoia.
Right. And that's the challenge when it comes to those weight bags.
We heard her voice.
We got a question in the chat.
Good. Hit us with questions.
Does the alignment need to be done with ADAS calibration all the time?
So
Good question.
that is a great question. And it is, so there are some manufacturers that are very, very clear that say, if we are calibrating a vehicle, we have to have an alignment. There are other manufacturers that say, if you make an alignment adjustment, then you need to recalibrate. There is a little ambiguity in most, but the fact of the matter is that with the thrust angle alignment, that was really one of the reasons why Lee Hunter is in the Lee Hunter, was it Automotive Hall of Fame, is from the thrust angle alignment. That was a big factor for a long time and is really coming to the forefront when it comes to ADAS calibrations. We're going to struggle with being able to calibrate a car correctly if the wheels are not pointed in the right direction underneath it. So it's critically important, if we look at the lower right, making sure that that thrust angle is pointed in the right direction, because if the wheels are going to kind of automatically compensate for themselves and have it rolling down the road, but the body is now looking off in the wrong place. So, if you're looking to do a top quality job and the most efficient for your technicians, making sure that it's on the alignment rack and that you've at least got alignment readings to show that that thrust angle is correct. And with the amount of rear axles that are adjustable significantly, it can definitely throw off a calibration quite easily.
And I want to answer this a slightly different way. And I love your question and I appreciate it. I think in the automotive industry, we are problem solvers. We are logical. We understand that this thing caused that problem and this thing is going to fix that problem. And sometimes it's easy to think, well, I didn't really mess with any of that. I shouldn't have to recalibrate it, whether it's a steering angle sensor or it's any forward-facing radar, any of that kind of stuff. And at the end of the day, for all of us as an industry, this isn't just collision, but it's anybody at a basic gas station or speedy lube that wants to check alignments. When the position statement from that manufacturer has said, under these circumstances, we're going to want to recalibrate that ADAS, that's really all it comes down to in terms of sleeping really good at night. Right. I think I have 6 children. I'm all about stress reduction. And when I know that Honda said, sure enough, if you replace this thing or you move that bumper, or goodness knows, your paint got a little bit too thick at some body shop, we know how those things can relate to it. You're going to need to recalibrate these things. And so for me, it's really a question of what is that position statement? How can I find out that position statement? And then how can I comply with it in a way that I'm going to be compensated appropriately for my services? And I'm not going to get spanked on the backside because I did something wrong.
Right.
That's how I take it.
Yep.
Good question.
Yep.
Okay.
Great.
And keep questions coming, you guys. If anything else comes up, if you have questions, it'll have to cool down a little bit before we're good.
Sorry, we might be a little dark for a few minutes.
So I think, yeah, so that covers our basic angles pretty well. We get through that, right?
Yep. Yeah. So we touched on thrust angle and thanks for the question, because that threw us right into that thrust angle. And let's just kind of retouch on thrust angle a bit. That is that angle of the rear axle, basically the box around the vehicle. So if we look at the picture on the lower right-hand corner, if we've been around the industry for a while, we remember Nova's way back when always had a dog tracking issue. Those are the kind of things that are going to affect not only our alignment, not only our tire wear, not only our customers feel and drive along the road, but it's also going to affect our ADAS calibrations as we continue to move forward with that. The other thing, so one of the things to think in mind with that, I always use, I like to use some of the stories that I run across in and around the industry. And recently I had a shop in that was in our training facility, and they were actually balancing some tires on the truck that had been in an accident. And in the accident, they had made a settlement with the insurance company, and everything was going to get taken care of. Was going to get taken care of by the insurance company. And what we found was, while the car was in the shop, we put the heads on it. We did a quick measurement. The body damage was a small section in between the back of the cab and the front and the rear wheel. So it was a very small little body hit. But that's all we had for information. The tires, everything looked good in it, other than this vibration issue. When we analyzed the vehicle, what we found was that the rear axle in that collision had been hit by the other car that had made the damage on the fender, had actually hit square into the tire. So it showed no damage anywhere else. It damaged a cord inside the tire, but it also sheared the pin in the rear axle and shifted that rear axle about 3/8 of an inch off center. So, and unfortunately, when we did that at our training center, it was after they had already made a settlement with the insurance company. So now it was on the owner to have to deal with that, or to try and go back to the insurance company and fight to get it right. And a lot of the vibration issue was accident related, because we really didn't get in depth with what was going on with that vehicle, and making sure that we've gotten all the readings that we need to get when we're doing that alignment.
I got a question in the chat.
What's
Does
that?
does the ride height targets eliminate the need for sandbags?
So in the BMW side, yeah, we've built specs in to be able to handle that and adjust for those airbags, or for the sandbags.
And I think that shows up on version 16 of the software.
Right.
I think is that where that happens, where the vast majority of the BMWs, is my understanding, not all of them, you still are going to encounter those sandbags sometimes with the BMWs, but it took a lot of that out of it.
Right.
Good
Yep.
question. Yeah.
The rest of the time, and we're going to show you later on today, a little operation with those targets, because those targets can also be used for other operations to actually see where the wheels are underneath the body, and do we have some subframe and body misalignment caused from the accident. So great question. I love that. That's probably one of the most underutilized tools that comes with any of our aligners, for sure.
And I say real quick version 16, because some of you may be operating version 12 or 14 or something like
Right.
that back there as well. So just be aware of it. Yeah, that version 16, they released that. And we're on version 18.2 right now. So just always get a little bit better for our consumers anytime we can. Okay.
Right. The beauty of the industry is that it's constantly changing, and we always have to be adapting to the newest information.
Yep.
One of the other things, real quick, as we kind of touch on some of those manufacturer nuances, is Mercedes-Benz is another one. If you've been familiar with doing Mercedes-Benz alignments, in a lot of the cases, we'll actually get a spec from them that is a laundry list of 30 different numbers, and it'll say a bunch of different options for the specs for camber and caster with those vehicles. And if you're at a Mercedes dealer, they have a tool called the Romas tool that actually has 4 little teeth on it that sit up into the control arm, or maybe sit on the axle, and will give the angle of the axle to actually give it an actual correct spec. And again, I think that software 16, that this tool that Justin has in his hand is capable to be used to get that angle, so that we're actually getting the right information right from the car with what that angle is. So depending on the air ride, suspension, that sort of thing, we're actually getting the spot on spec and doing the alignment correctly.
And that's how they're measuring ride height, based on the angle of that lower control arm. That's
right.
That's what
Yep.
that's all about.
So
Is that available to the aftermarket or only Mercedes?
that is.
Yes, there
yeah.
is. Yeah,
Thank you.
you can get this right through your local Hunter or sales or service representative. I don't know if you can buy it on the website yet, but
I think you'd have to go through a rep to get that one, but yeah, that's available for, like Justin said, any of the machines with 16 on up would be able to be able to connect to that unit. The Mercedes unit is a different brand. It runs in a cradle, and it downloads information and things differently. So we've put together one for the aftermarket space that is very efficient and very cost effective. So
hey.
great. Perfect. All right. You want to switch over to the presentation there? All righty. So it's all about asking the right questions and making sure that we understand what's going on with the car. So we do have
Yeah.
a little bit of feedback.
It's fine.
We're good.
Okay.
Yeah.
I'm gonna unmute when they ask questions. They'll be louder, and I'll mute you when you talk.
Awesome.
Perfect.
So yeah, information, when we're talking about gathering information to do a good alignment, we're gonna need information from a number of sources. We already talked about the customer and kind of asking them their opinions. Y'all got that questionnaire for things about the vehicle. So getting information from the customer is a great way to start, but then we need to drive that vehicle if humanly possible, right? And I know, goodness knows, in a collision world, you're gonna have different phases of completion where sometimes it's drivable, sometimes it's not. But we're going to road test it to gather some very specific information as well. Again, assuming you can get out of the road. Does it drive straight? Find you a nice flat level section of road where you can find out whether or not it's going to pull to the left or to the right. That's very valuable. We want to find an area where we can do stopping and starting. You want to be using those brakes, accelerate, see what it does under those circumstances. If I've got weird things happening as I'm stopping or starting, maybe something is still shifting on this vehicle. Maybe I've got bushings that are worn out on control arms or something like that. You're going to want an area where you can turn all the way lock to lock. I like to tell folks, get it a full swing to the left, full swing to the right. We want to feel all of that steering linkage go through its full range of motion to make sure none of that is binding up and kind of holding things back. We want to see that it returns back to center appropriately as well. And then we need an area, and I know there's a little bit of out of order there, it looks like, right? But we need an area for a dip or a bump in the road. And this is all about symmetry. When your suspension compresses and expands, similar things should be happening side to side. And when we don't have that going on, when we don't have that symmetry, and you body shop guys, I know you know all about things being symmetrical, you're going to have steering that's going to do some weird stuff. As it compresses, my toe on the front, my total toe should come in and go out like that. But sometimes when I've got maybe something that's just a little off level, maybe some tie rod ends that aren't quite threaded into the same distance on either side, as it compresses, you may find that maybe one wheel stays straight while the other wheel turns, or they'll both turn the same direction. That can give us a kind of a startling experience going over a bump or dip in the road where your steering's going to actually pull over to the side and then correct once we get back to level. But just in that bump or dip experience, we want to be sure we feel that as well.
And one of the great things in that is that we're identifying things like a bent spindle, a bent tie rod end, a bent inner tie rod end, things that later on we'll talk about how we can utilize the alignment machine to be able to actually take measurements, provide documentation to the insurance company for it. But those are the times where you may feel those kind of things. And you know, as I was talking about with the truck having that accident and the impact going through the tire, when you consider somebody that is, you know, going through a pothole, is 25 G-forces of force getting absorbed by that tire as a car goes through a pothole. So imagine what that is in a collision when it impacts a curb or another vehicle, and all of that force gets shot through the tire can't absorb all of it. Some of it ends up going in through the suspension and will bend one of those components. And when those components bend, now all of a sudden it will give us that weird feeling when we're driving it that we want to be able to then go and take measurements to be able to prove to the insurance company, hey, we've got to replace this spindle because it's bent. And we've experienced it. We know what it's doing, but we also then have the documentation to show this is why we know that it's bent.
And without using those diagnostic angles, you can have a vehicle that actually looks like it's doing pretty good sitting on your rack. So that you could send it to an alignment shop and they send it right back to you green, but it doesn't necessarily drive straight. You could still have some hidden damage in there. That's what those diagnostics are all about, helping us to locate other things that just aren't quite right.
Right.
Slide.
Yep. There we go. So we're just kind of revamping. This is really one of our alignment screens. And if we jump back to the other side, we have a couple different views. You want to jump over to this one. So this is kind of our numbers view, great for the insurance companies. Here on the screen here, we have what we call our virtual view, where it actually looks like a car. There we go. So where it actually looks like the car and shows us the information that we're, you know, that our core angles that we're looking for. So there's a bunch of different ways to look at the information to make sure that we're getting what we need for the technician to make the right adjustments. So you want to jump back over to. And then we get into those secondary measurements. So let's talk about some of those names. So we've talked a little bit about the camber caster toe, which is really our maintenance alignment, you know, our core three. Now we're into those secondary measurements and what they can tell us about the vehicle. So we have things like the included angle. So in the included angle, Greg, if we can jump back to the car. So the included angle is really, that one, there we go, is that angle between the wheel here being straight up and down and that pivot point that Justin was talking about, but how is it leaning backwards? Or leaning towards the center of the car, where Justin was talking about that pivot point going at an angle through the wheel. This is including the angle from the face of the wheel to the angle of the strut. And that is one of those angles that's going to give us a little bit more information.
Right. So where that steering axis, just to dive on this, just a smidge with that. Yeah, the steering axis is still the steering axis, right? So we talked about it in terms of caster. How is that leaning rearward compared to a vertical line being our steering axis? And then sure enough, if I look at the vehicle from the front, that axis is also leaning inward, as Steve just mentioned, right? So that first part of it, though, is the steering axis inclination.
Right.
How far it's leaning in like that. And yes, the included angle then is the steering axis inclination plus whatever the camber is doing on that wheel, right? So I love the way you talked about the face of the wheel and what that's doing there. So yeah, just we got a bunch of different angles here to try to help you guys out with that.
Let's jump back to the presentation. Yeah, so, yes, we included, we have the steer head. We also have our setback, which is going to be a critical one in the collision space. So if we kind of position or talk about this car as a square, so let's jump back to us again more. So if we talked about this car as a square, actually, Greg, you want to go to the other camera? Oh, it doesn't really get us. Never mind, moved it. So if we had this car as a square all the way around it, it's where are those wheels when it comes to the.
That's good.
Perfect. So if we have a square around it, where are those wheels in relation to each other? So is this wheel pushed back a little in relation to the other front wheel, or a front wheel pushed forward? That's where in the truck that I spoke of earlier, there was a little bit of damage right here that then pushed this wheel back a little bit. So that made our thrust angle off a little bit. So these are angles that we're looking for to make sure that our vehicle our axles are all positioned underneath the vehicle the way they're supposed to. So all of these angles, as we build up more and more information, we start to do some calculations with them to determine what item is bent. So this one.
Do you still have the chart that you can use when
Hold
you
on.
check an SAI to show you what's bent?
Yeah, so the chart with if you compare like SAI and included angle and all of that, that actually should be in all of the handouts that were sent to this. That is a part of the, oops, let me jump back in there. That is a part of what we do in our level 3 training class, with a 2A training class for it. I did include that in this for this group, so that you have that, and it depends on what the suspension type is. Is it a McPherson strut setup like what we have here, or if it's unequal lateral arms, all of the different types of suspensions, and how does that equate to which components to look at? And one of the things that I like taking that chart actually shows a lot about SAI and included angle and camber and caster and toe. It does not really overlay that wheel setback. And when you put in the wheel setback with it as well, that narrows down that damaged component even tighter. So that's a little bit more accurate, a little bit more information that we can provide to the insurance company to show them, hey, this is why we're replacing it. Instead of we need to replace a whole knee, we're telling them we need to replace the strut, and here's why. Here's all of our data. Here's our comparison chart to tell us this is exactly what we need.
Thank
you. Yeah. Very powerful tool that's part of it all. Yeah.
Presentation. All right. You want to?
Yeah, well, yeah, let's just talk about this for a second. Right here, this being the secondary measurement screen is a funny thing too, oftentimes. Now we teach this in our level 3 alignment class, as Steve mentioned, and most people have a Hunter alignment machine and have never seen this screen. They didn't even know it existed. So this is a lot of powerful data for what you're gonna have in there. We talked about included angle, setback there, and then we go into some of our steering angles as well, okay? And so turning angle difference, let's talk about that, just as for instance. So we've got a situation there when you think about what a car has to do to make a turn. My front tires, if I'm trying to do donuts in the Walmart parking lot, whatever it is, those tires can't turn at the exact same angle, because as we're making a circle, the outside wheel is actually a different diameter than that inside wheel if I'm just turning in a straight circle. So my tires have to turn at a different angle when I'm turning. Say you're turning to the left, I'm gonna go this way for you. My left wheel is gonna turn sharper into that turn than the right one, and vice versa. We call this a turning angle difference or an Ackerman angle. There's a few different ways to out on turns, a few different ways that people that refer to it. But that is another very real diagnostic angle to make sense of what is my steering system doing. You can imagine that if I've got some damage in there, be it a tie rod end or something going on with my steering.
I see a lot of knuckles where people will say, hey, I think there might be a knuckle and things. That's where we find that in that process, because that arm coming off is cast iron. It got a little bit of a hit. and it tweaked it a little. It's not something that we can easily measure without
Right.
having the alignment system to measure that whiteout on turns to see that difference from left to right.
And where it can still be perfectly normal toe when I'm sitting on the rack.
Right.
That's where it's kind of tricky, because then if there are known variables there, how far is that inside wheel going to turn one way or the other is kind of a known variable as an industry. And so we can check and confirm that those are doing exactly what they're supposed to do so that we can indeed isolate those damaged
Right.
pieces.
And as we talk about symmetry from left to right, every car is built where it's, they've got to make left turns and right turns.
Yep.
So it's typically a standard reaction between it. When we have a bent or damaged component on one side, we typically will see a variation in those numbers because they're no longer following that same symmetry. And that then highlights it out for us that, okay, here's where our problem, here's where we're going to start to look. Now we're going to lay over those other numbers, that included angle. We're going to lay over the wheel setback to determine, is this that the steering knuckle has been bent? Or is this that the control arm is bent and it's causing a different reaction with the steering knuckle? Or the strut, sometimes you see them where the strut get kind of kinked right at the mount. It's notorious to alter the turning radiuses of it because of now the angle of that knuckle, instead of the arm that comes off the backside of the knuckle, instead of it being, let's say, level, it's now actually pitched downward a little bit. So instead of it turning on a level twist, it's now turning on an arc and causing that toe to go out of whack when it goes around that whiteout on turns. So rather than going to the Walmart parking lot and doing donuts and trying to figure out, is my skid pattern different from side to side? Though it would be a fun way to do it, probably wouldn't be as accurate. And as a shop owner, you might not want to have that happen in your shop. So we put that into the equipment to be able to give us that measurement. And it is an industry kind of standard across the board that those measurements should be in there, should be in basically any alignment systems. And it's just, in most cases, like Justin said, that screen's in many alignment systems, but nobody knows that it even exists. And then once they do know that it exists, how do you deal with it? How do you use that information to impact your business, your customer's vehicle, that sort of thing?
Yeah. So the next one I think down our list, I believe, is maximum turning angle, maximum steer, right? So maximum left steer, maximum right steer. That is where we are similar to our turning angle difference. Maximum steer is going to be how far can it turn all the way to the left compared to all the way to the right. And this is another one of those scenarios where you may be dealing with bent turning arms. You may be dealing with steering stops that are out of adjustment or damaged, perhaps. Maybe bumper type apparatus in there that are just gone. Maybe a steering gear that's mismatched and missplined a little bit with its output shaft, or damage even on that output shaft. All of those kinds of things can cause us to have a maximum steering, maximum turning difference side to side.
Yeah, one of the interesting ones that I've seen in the past is I know it's happened a couple times on Dodge Rams in particular, but I'm sure it's happened on many others, is actually the sector shaft coming out of the steering box, where it's a spline shaft that the pitman arm is connected to, that it actually in the impact got enough of a shot that it literally twisted the splines.
Sure.
So, the pitman arm will slide on and off, but when you take it off, you look and the splines are actually have a little bit of a hitch to them. And that creates an issue with that max out on turns, that it's now a quarter of an inch or so off at that steering sector, or an eighth of an inch off at the steering sector, which makes a huge impact at the wheels.
How far you can turn,
move out
either direction. Yep. Great.
So
a couple of other measurements that do show up on there are things like our wheelbase, right? Our track width. Very valuable bits of information when we're looking at what is a vehicle doing. Have we found ourselves here with some kind of a diamond shaped frame, that kind of a stuff? So lots of things that we'll be able to show you real-time measurements on the alignment machine a little bit later.
Yep.
Yeah.
Great. It's interesting. I had a customer that was doing collision alignment assessments. They looked through those numbers, and the numbers, they compared it to the chart, and the numbers seemed really, really screwy. And so he called me and he said, "Hey, can you look at these numbers for me and see what your thoughts are on it?" And I looked at it and I said, I would almost guarantee that this frame is bent on this car, the unibody on it. It was a Honda Pilot. And I said, can you send me a picture of the impact? And he sent me a picture of the impact. It was not a big deal. Was a small impact on one corner. And I said, you know what, I would really do a measurement on the unibody up front. And sure enough, he measured, took his regular measurements, brain measurement system, and measured out the strut towers and the unibody structure in the front of the car. And it was shifted over about 3/4 of an inch.
Sure.
The insurance company ended up totaling the car. Fortunately, he did this in the beginning, before he had actually done it. And,
Right.
you know, afterwards he said, you know, this saved me about $6,000, because if it was before where we were always just aligning at the end, I would have fixed this car. I would have done all of the repairs on this car and then gone to the alignment, send it over to the dealership to have them do the alignment. And it would have not been able to get into alignment because the unibody was bent. The insurance company would have totaled the car still, and I'd have been eating that $6,000 repair. So there's some real, you know, nuts and bolts dollar amounts that affect the shop when it comes to these numbers.
Yep.
So, and then we also have the same information in the rear as well. And one of the things with these all of our complex angles here is we have the ability to identify if we've got a subframe that is misaligned. So many of you probably have heard in the shop where somebody cracks the first bolt of a front subframe or a rear subframe, and it sounds like a gunshot going off because of all of that tension that was built up in that subframe. We're also going to be able to read those numbers in the rear of the vehicle to identify, did our rear subframe get shifted and is causing a lot of our problems? And in some cases, the machine's just going to even kick up a warning to say, hey, based on these numbers, we need to do a subframe realignment. And they'll, in a lot of the cases, it'll actually have a procedure to show you how to do that. So, great. So we talked a lot about those primary angles, camber, caster, toe, rear toe, that total geometry, and then into the diagnostic angles. We're going to jump through a couple of them here. So, yeah. All right.
Yeah, we're good. We talked a good bit about that, I think, in terms of what those angles kind of are. We'll go as far as you want us to go.
Yep. So well, let's jump back to the presentation for right
Sorry,
now.
I misinterpreted that data. Sorry.
Yep. So, and just keeping in mind that negative camber that we talk about, not only, you know, especially in the front end of the car, even in the rear end of the car, that typically means that our car has settled, and that has implications now with our 8S calibrations down the line. So we want to be very cognizant of those negative camber readings, that is potentially an issue of going forward when it comes to those calibrations.
And I want to tap on that real fast with that, Steve. The idea of camber. Let's just talk about, just to reiterate what we talked about a little bit about those BMWs before and all that stuff. Because from a diagnostic perspective, when I'm dealing with alignment on a vehicle, over time, just like you and me, like all of us, these cars are all going to get a little bit shorter. Those springs are going to settle. The tensile strength of all these things is going to evolve, and they're going to deteriorate. So under normal circumstances, the entire vehicle gets a little bit lower, and all of that camber does, sure enough, go negative. It's when we see that one side looks pretty reasonable and the other side has gone way out of spec. Of course, we know there's some kind of a damage there. That's where we start thinking about these diagnostic angles and how can we utilize them to help speed up that discovery process.
Absolutely.
So yeah, normal camber all around, going negative, no big deal at all. Right? Tradition. Okay.
All right. Next up. So caster is again this is one of our kind of our quick number to get. In most cases, it's not adjustable, but it's really probably one of our most critical diagnostic angles in making sure that we're able to identify damaged components. Oh, we're gonna go back to the presentation. Sorry. All right, so just to reiterate so that we have it kind of for everybody, when we look at positive versus negative, so straight up and down is 0, leaning towards the front is negative caster, leaning towards the back is positive caster. So if any of you have driven a Dodge Ram back in the day, so 70s, 80s, 90s, they were notorious, actually probably not even up into the 90s, they were notorious, even in Dodge trucks, for death wobble. And things. It was a little bit about the angles of the suspension that would allow that truck to kind of shimmy and shake. a lot of that had to do with the way that the caster was in that truck. And there was a number of shops that would fix it with replacing some suspension components and then changing that caster angle and actually pulling it back, which that is your angle that is not only going to be a diagnostic angle for us, but that's going to also change our steering effort. So the more lean back that we are with it, the stiffer that steering is going to be. So again, remember, as I was talking about that arm turning the steering knuckle, the more caster that I have in it, the higher that arc is going up and going down, which means I've got more steering effort into it. So race cars, a lot of times they like to put a lot of caster in them so that the driver doesn't feel that it's loose at high speeds. But it's one of those things where it's, you know, it's the diagnostic angle, but it can also be one of those things, if the angle is off, our drivers are going to feel it, not in pulling, but more in my steering effort isn't as good, or my steering return isn't as good as it was before. So things like the car, you know, if you go around a bend and the car naturally wanting to go straight again, that is caster that's actually driving that process of a natural return to straight ahead.
And by contrast, any of you who've ever driven a forklift, you'd understand what zero caster feels like, right? Because you turn to the right and it just kind of keeps going to the right until you correct it. That's the opposite. That's what you have when you have no caster.
Yep.
Sure.
Good. All right, so I think we hit on that one pretty good. The caster measurement, that's a good depiction of it going through those turns. So we're just gonna jump through. We'll jump through a few of these. So this is, I want to touch on this one. Caster has on some cars it is adjustable. You know, if you got a Ford truck or a Chevy truck, that sort of thing, an A-arm system, they're typically somewhat adjustable. But in the collision space, in a lot of the cases, we're in the lower right-hand corner. You got a strut mount that is like that. There is no adjustment to it potentially. This is one of those times where we got a lousy caster reading. It really necessitates us going and doing our traditional unibody measurements to determine, is our unibody actually in the right place? Is our control arm bent? You know, or is our mounting structure bent that's causing us to have our caster go a little bit sideways? So jump back to that one. All right. And then toe is a big animal, as we talked about a bunch with this, making that toe in or toe out adjustment correctly. If you notice on almost any alignment machine, that is actually far more detailed in its number. It goes down to thousandths of a degree instead of hundredths of a degree, because it is looking for, or actually, no, I'm sorry, it's going down hundredths of degrees, not tenths of degrees, right?
Right, for towing.
Yeah,
Our towing.
Because it's pretty critical.
Toe is our most crucial alignment angle when it comes to tire wear. It impacts straight line stability. It deals with our steering wheel, right? So total toe, as we've talked about before, about how like that stuff changes in motion too, right? So I have to believe that you guys are doing collision work on modified vehicles also. And so as we talk this through, I'd like to plant a couple of seeds of thought for you. All over the country, we're doing classes going through all of these things specifically for shop owners and technicians. And we've got, I think, 51 training centers around the country right now. Our level 1 alignment class really goes through a lot of these foundational angles and understanding what are our causes of troubles, et cetera. But the level 2 alignment class deals with modified vehicles. And I think you'll grasp this pretty quickly, just the notion of it, because if you are currently doing modified vehicles in your collision shop, which again, I imagine is pretty normal, it doesn't take much to kind of modified, right? Just a different wheel and tire combination on here. I can take this car and put only taller tires on it, and suddenly I've changed how it's going to react in terms of that total toe. And this is all about leverage. It's all about leverage. Imagine most shop owners are most car owners that are modifying their vehicle. They're putting a different wheel and tire package on there. Maybe it's a little bit shorter, maybe it's a little bit wider, maybe a more negative offset kind of a tire package situation, right? If I've got that wider tire put on a vehicle that was aligned to factory specifications, that wider tire has a different kind of leverage associated with it. It's going to be pulling those tires more rearward. So what I mean is, if I put a wider tire and wheel assembly on here, think about the forces pushing rearward. You may be familiar with rolling resistance. That's kind of the difference between an off-road knobby tire and some Jeep, something like that, and a Toyota Prius. A Toyota Prius tire is very fuel efficient because it's narrow, it's very smooth, and it rolls very easily. The wider assembly I put on here, the more friction is created on that road surface and it pulls it rearward. So if I've got modified vehicles and I'm aligning them back to their normal specifications, it's not going to go well because it's going to flex into a different position. Okay, so that's one of those thoughts we have to have as relates to tow stuff as well. So be aware the modified vehicle alignment class is a 2-day class taught all around the country. We'd love to have some of your people there. You can find the upcoming dates and issues and locations by going to hunter.com and follow the points to click for training. We're here to serve. Okay, so on with the presentation there about tow. Moving on. Love it. Whoa. Oh, yep. Okay. You want to talk about all that? Okay. I'm gonna
Let's hit on individual tow a little bit.
Yeah, well, and I would like to, let's do it from the angle of, let's talk about probably the most important thing you can do in your shop in terms of alignment is to be sure you've got the truth right out of the gate. All of these tow numbers are based on different reference points in the vehicle, right? And those reference points are created by the targets being secure, being mounted appropriately, and figuring that stuff out. We were talking about how the tow angles are measured in hundredths of a degree, right? So that is picky stuff. So if my target is mounted different from one side to the other, imagine that I've got maybe a spare wheel, maybe a slightly different scenario where for some reason or another, they've got hubcaps that are mismatched or something like that, and we're doing it over the hubcaps, which you can put them over hubcaps, but we would certainly want them to match side to side because the positioning of those targets at the wheel face on both sides creates a center point. That center point on the front of the rear is going to be a consistent reference point for those rear tow numbers, which are creating our thrust angle, showing us where that vehicle is pointing. That thrust angle then, layer upon layer of importance here. My geometric center line has to be accurate so that my rear positioning is going to give me good thrust numbers because my front toe is all going to be referenced off of that thrust angle. Now, a big challenge we see in shops is that the rack itself may not have been maintained very well. Okay. Can I touch on that real fast?
Yep.
Okay. So this is a common concern. If we have people that are reaching out to us saying, hey, I'm not sure what exactly is happening, but maybe I'm getting some crooked steering wheels. The first thing we're going to see oftentimes is the condition of that rack. Now, a body shop's a pretty clean place, except for all that dust and debris. Just kidding, you guys. So what happens in an alignment rack, ultimately, thank you very much. I'll try not to get too far away from you. In an alignment rack, underneath are split plates and our turn plates that allow the vehicle to be in its neutral position. Super important as I'm making adjustments on a vehicle that the vehicle is able to relax and be kind of neutralized because that's the way those specifications work. Okay. You can see the whole vehicle sliding back and forth right here. Now, if your turn plates and slip plates aren't moving freely, meaning they can't easily slide around on here, then we're not getting the truth because it's not pointing necessarily where it's going to be when it's going down the road. So the debris and the dirt and the sand and stuff like that can get up inside your turn plates on the front and the rear, slip plates back there, is really hindering your quick and easy alignment work if that's something happening. So we want to make sure that you're looking into maintaining that thing appropriately, which includes a lot of blowing compressed air between that gap to keep everything cleaned out in there. Sometimes over time, it's going to need a little bit of love and maintenance. So I want you to be sure you reach out to your local Hunter TNT representative. And I would encourage you on this. In the moment, I have no earthly idea what type of Hunter or what type of alignment equipment you're using, brand X or anything else like that. The same statement is going to be true. For you to be getting good alignment work out of it, those slip plates and turn plates are going to need to be able to move freely. So whatever you're using, look at that at your shop. Next chance you get if you are doing alignment work, take a look at that. And the best way you can probably do it is to put a vehicle on the rack. Am I still in frame yet? Put a vehicle on the rack and from the rear, grab it and see how easily it moves back and forth like this. If you find with the weight of a vehicle on there that you're not able to move it around, you're going to need to do some maintenance on that rack. Again, whatever brand it is, we're not worried about that. Take care of getting that rack where it can move freely, and you're going to have a lot more success with your alignment work.
And I wanted to touch on one other thing that Justin talked about. So in the industry, we use a lot of gunny wheels that work great. So when that wheel gets shattered in the accident, we're going to throw a gunny wheel on there. make it really easy to move it around the shop and that sort of thing. Keep in mind that we want to make sure that when we're sending it to an alignment shop or we're doing the final alignment in our bay, that we are doing it with the factory wheel on it. So that geometry is right, because a gunny wheel has almost no offset, and almost every wheel is going to have some sort of an offset. So that we're not going to get as consistent an alignment unless we're utilizing the actual wheel that would actually go on that vehicle.
Absolutely. Great. So that's all foundational truths about alignment stuff for sure.
All right. All right. So, one of the things that when it comes to tow and things, having a steering wheel center, that is probably the #1 complaint that we hear from across the industry. If it's a maintenance alignment, collision alignment, whatever, that is the one thing that a customer feels the most when they've had an alignment done. So we want to make sure that is critically important, that as we're going through our process, that we're continually centering our wheel and making sure that we're following the steps of that. And if you go back to us, I want to show everybody this little tool. If you've probably seen that in your shop, it's a steering wheel holder that goes between the seat of the wheel and on the bottom of the steering wheel and hold it in place. And so many times I go into shops that are saying, hey, I've gotten crooked steering wheels. And my first question is, are you using the steering wheel lock every time? And I get oh yeah, every time religiously we're using the steering lock. And I tell them, did the aligner tell you to use that steering wheel lock? And they say, well, no, we just use it every time. Our alignment system is designed to tell you when to use fixtures like this or the brake pedal depressor. If you are doing a tow adjustment with wind tow, you do not use this except for certain vehicles that will specify, go get your steering wheel lock and lock your steering wheel in center. If you're using it for a vehicle that doesn't have it, you will end up with a crooked steering wheel in most cases.
And I would say if you're using it and you get a straight steering wheel, then that is fantastic, right? That is perfectly fine. But exactly that point, our wind tow software came out in 1993. That makes it
It's
old now. 33 years old this year, I think, right? Oh yeah, just a little bit. So it came out in 1993, and it has been getting straight steering wheels for multiple decades, and I would say without worrying about greasing up the seat, without causing those things to happen. So yeah, certainly if it works for you, that's wonderful. We'd like you to know that we have a default method in our software for decades now that allows us to get straight steering wheels without having to worry about all that.
Yep, absolutely.
Yep, love it.
Yep.
Great.
All right. So geometric center line, I like to touch on that at this point with it, because with the ADAS calibration world, geometric center line is a critical piece in what we're doing. We need to make sure that our vehicle wheels are lined up correctly underneath the car, because again, now we're mounting cameras and radars to the body. So if the wheels are not positioned correctly, that allows our body to be off kilter from where it's supposed to be. So we want to make sure that we're doing the best for our customer, that we're getting the best calibrations and that sort of thing, but we're also protecting our own business and making sure that that vehicle is calibrating correctly, and it is as quickly as possible. So in a lot of the cases, we have people, we have a lot of manufacturers that do dynamic calibrations. And dynamic calibrations are ones where you're going out to drive the car in regular conditions, 25 to 45 miles an hour, lines on both sides of the road. If there is a mechanical issue where the geometric center line is not right, the thrust angle is not right, the alignment's not right, we may be able to get a successful calibration, which is great, but that may have taken 30, 40, 50 minutes for it to meet and all of the requirements that it needed to in that time frame. Or we may not even get a good calibration, and we might have a technician out driving down the road for a half an hour, 45 minutes, unable to get a successful calibration. And it's really not because of anything with the ADAS systems, it's we've mechanically not put the car back together the way it's supposed to. So. And that jumps right into that thrust line, making sure that we're pointing in the right direction. So geometric center line is that center line of the body. The thrust line is that thrust line of the suspension, making sure that the suspension is rolling down the road We've probably all seen that tractor trailer driving down the road where you can almost read the side of one of the truck, Yep. That you can read the side of the truck on one side and you can't see it on the other side, or you could see the entire side of the cab up front because the trailer is tracking, 8, 10, 12, sometimes 18 inches off behind it. That is that dog tracking of a thrust line that is affecting things. That's just one of the quick and easy ways to see it. So making sure that we have that brought in the line. And with the rear, for years, people had said, oh, thrust lines, unless I've got damage to the rear axle, it doesn't matter. But in today's cars, it could be a crossbar or a tie rod end in the back that is causing that, or a track bar that is causing things to be off-centered, that is an adjustable or repairable piece. One of the things that I see a lot in the collision space is a post-accident, customer has a front end hit and the insurance company wants to fix the left front corner or the right front corner of his car because that's what's been hit. But in the accident, we drove over a curb and down into an embankment a little bit. And the tow truck operator had to get that truck back up on the road. So they took those big honking J-bars that they all love to use and just went right up to something underneath the car. And they hooked it on a lower control arm and drug that car back up the hill and onto the road so they could put it up on the rollback, then damaging those control arms. So we've got a front hit on the car, but we actually have rear damage that's affecting our thrust line or are affecting our wheel track because of it. All right. So there's positive and negative depending on which side we're going to. And again, in today's world of ADAS, are we looking at the side of the road or are we looking at the oncoming lane? If our thrust angle is off, we know that, we'll go back to the camera. If we know that the thrust angle is off about 1/2 degree, that's 3 feet at 100 yards. Most of our cameras and radars are looking 200 plus yards in front of us. That's a little over 6 feet in one way or the other. So either it's looking at people's mailboxes or cars sitting in their driveway, or it's looking at oncoming traffic. And when we think about if you've ever experienced an automatic braking experience, it typically doesn't say, oh, geez, I think something's coming. Let me slow down. Let me hover my foot over the brake. It goes, oh my God, something's coming, and bang, it jams on the brakes and stops you dead.
Terrifying.
It is quite a jarring experience. So we don't want it to be doing that inaccurately and doing it, leaving you in the middle of traffic with a car right behind you. We know that most people in the world don't tailgate today, but sometimes you might find 1 or 2 that are right behind you and don't react fast enough and impact you because of the calibration. So we want to make sure that the cars that we're putting out of the shop are 100% right, accurate, and that it's not going to provide the end driver that kind of an experience. So, all right. So dog tracking, that's really that kind of that truck scenario where we're off to the side. So we'll jump through a couple of these. So one of the things that I do hear a lot in the industry right now is that there's a few insurance companies and things that kind of push back and say, hey, we want to do a 2-wheel alignment on this car. And we want to make sure that realistic for us to be able to accurately identify where that car is in that alignment. We're putting all 4 heads on. It's getting a 4-wheel alignment with it. The days of a 2-wheel alignment are really years gone by.
Pretty far behind us, yeah.
Right. So if you're in a situation where there's an insurance company that's kind of pressuring you that, hey, we want to only pay a certain amount for a 2-wheel alignment, really not in the world. And in 99% of the cars on the road, it's not going to give us accurate information for what we need, not only for alignment and customer drivability, but also when we get into the ADAS calibration space. So we want to make sure that we're talking consistently about a 4-wheel alignment. And in that, we're looking at that thrust angle of the vehicle. So, all right. So again, that's that total 4-wheel alignment where we're getting our rear camber caster toe we're doing our front wheel alignment. If you're not doing alignments in your shop, this is a, one of the things that I would think about if you're gonna add it to your shop is, what are some of the things that the tools can provide me to help me be able to do that? So we want to make sure that you have something that's going to actually walk you through that process, because one of the things we don't really get in depth with anymore is the order at which things get done. And we always start with the rear and work forward. We work forward to Sorry, completely lost my train of thought there.
I try not to distract you.
Order
The order of what we're doing our adjustments.
Yeah.
So we want to make sure that you have something that is kind of walking you through that process. We always do the rear first, get our camber caster and then toe in our rear, then jump to our front and our camber caster and then toe as being that critically important space for it.
Do alignment technicians just have to know everything to do, or is there anything that can help them?
Well, so that's like our express align system is a critically important, is a huge step. And that's why I say, if you're not doing alignments, obviously the hunter reps would love to come in and show you what we have for capabilities, but that is I think that's a differentiator.
Yeah.
In the tools, an aligner is not an aligner is not an aligner. Yes, they will all give you alignment numbers. The critical pieces is it repeatable, accurate, and repeatable? So if I got my numbers on this car and I drove it down the road and I brought it back in on the rack, will I get the same numbers on it? So we want to make sure that they're repeatable, but then we also want to make sure that it helps our technician be as efficient as possible.
And I want you to understand that I mean that from one perspective, that you may be using a hunter alignment machine that never tells you anything to do. And that's one of those things. There's a setting, there's all kinds of settings on there for you. This isn't trying to sell you or talk you into a hunter alignment machine, by the way. If you have a hunter alignment machine and it wasn't walking you through the correct procedures to do that alignment, you might speak to your local reps as well to let them change some of those settings there for you. Because sometimes the guy that used to do alignment work for you, he did not need any help, but now you've got the 21-year-old young man, young woman who's trying to figure this stuff out. And there's a little bit more involved there, and there's a lot of help there available to you.
Kind of point out the express line on the left side.
Yep. For instance, okay. In fact, let's take a look over here.
He's got the screen up right. Yeah.
Right, so you see the purple mouse over here. Now, a lot of times when people fire up their alignment machine, once you got your initial reading, it says express align procedure. You may see this right here on the right-hand side of your screen. This is literally telling us what do we need to do on this vehicle right now based upon the VIN number and its current condition. And a lot of folks will just kind of X that out of the way and go on about their business, maybe go over here to the bar graphs or whatever, something like that. But I want you to know that, yes, if I've got a technician who just doesn't know what's the next thing to do, then he can click right on this express line, red letter, finish line flag, and it's going to take him right down that path.
Sorry.
Okay, no worries at all. It will take you right down that path to show you exactly what to do.
Yep, step by step. So we are right about halfway through the presentation, the class.
Sure.
So what we want to do is take about a 15-minute break, 10-minute break.
What do you say, Ron?
Questions first? And
Yeah, let's
I'll
start
do
with
this.
questions.
Any questions, then we can break if they don't want to, and let me do the speaker thing. So any questions? Yes,
Right.
no?
Yeah, Ron, does anybody have any questions for us? Is there anything we can do to be helpful before we take a quick break?
I don't see anything in the chat right now, so
Okay, super. Then it is 11:22. You want to say it about what do you think? Is 10 minutes good for you, Ron?
that's good. Yeah, just remind me to start the recording when we come back again. I'll pause it for now.
Okay, fantastic.
Perfect.
So we'll be back in place about 10:32 or 11:32 our time.
Yep.
Okay.
On the 30.
We good, Ron?
Okay, we're recording.
Okay, welcome back, everybody.
Thank you. Thank you guys for entertaining us for a break, and hopefully that gave everybody a chance to have a little get a sip of something and use the restroom and things. So we're going to jump right into the advanced angles, so the alignment diagnostic angles. So we're going to jump right into those. We've talked a little bit about them. We're going to kind of deep dive into these a little bit more. So those angles that we're looking at are steering axis inclination, included angle, setback, our turning angle, our max steer, and then those symmetry measurements that we talked about earlier. So our goal in these numbers and being able to look at this information, be able to document this information, is that we're able to identify, do we have a bent strut? Do we have a bent control arm? Do we have a bent spindle? Do we have, what components are the issue? That are causing our problems, steering racks, steering sectors, that sort of thing. We're utilizing this as a way to measure that information, but then to also document it so that when we go to the insurance company. So, one of the things that we hear a lot in the industry is we jump over here. We hear a lot from the shops that will say that they're gonna replace a knee, or we hear from the insurance adjusters that the shop wants to replace a whole knee on this car because something's bent. And, as the title of our program, when we have our alignments being outsourced at a maintenance shop that is doing our camber caster toe and our basic stuff, they look at the system and say, well, there's no way to adjust this, so that means something's bent. And they hand you that maintenance alignment printout back, and that printout gives you very little or no information about what you need to determine what's bent. So by us doing this, we're now documenting for the insurance company so that your insurance adjuster, when we think about it, everybody that's coming into a shop, if it's a repair shop or if it's a body shop, they're selling the repair to somebody else. If that is it's a repair shop and I'm selling it to my wife, I just spent $1,000 on the car, or a kid selling it to their fathers, or their mothers, or even just selling it to your neighbor why you need to do it. Insurance adjusters are no different. They have to sell it to their next level of management, as well as in a lot of the cases, you guys are probably very familiar with subrogation of claims. So if this car was in an accident, that because Justin hit it with his car, that he's now, his insurance is responsible for it, but my insurance is gonna pay to fix it. And then my insurance agent is gonna subrogate that claim. Well, if they've paid for an entire knee, that subrogation process could eliminate that payment from that insurance company. So they want to have all of the details and all of the documentation. So when they go to subrogate that claim to Justin's insurance, that there's no question they're going to get paid for it because these components were bent, and this is why they were bent, and here's the documentation showing it. So really, with all of this, we're looking to document that. As we get a little later down in the presentation, we'll talk about how you can utilize that documentation to supercharge your business as well. So let's jump back to the presentation. So we're going to deep dive into these a little bit. And I love these pictures, and the reason I wanted to include them was because it kind of shows it a little bit closer. So we have that steering axis inclination that Justin talked about earlier, and this is. All right. So this is showing those angles. So as we were trying to kind of illustrate that with our hands, this is really what that steering axis inclination is. And if we look across the bottom where that green circle is, it's showing that control arm is bent and altering that angle. And so the angle that we're looking at is the angle to the, kind of through the middle of the strut as our steering axis inclination. So, then we get into that included angle. So this is where we're talking about that angle of straight up and down versus where the wheel actually is as another angle to be able to help us identify what's bent. So if we notice on this picture, on the right-hand side of it, left-hand side, right-hand side, that strut is bent a little bit in that, there we go. Where,
I was trying to use your mouse to highlight what you're talking about.
so right here, it's showing that we've got a little bit of a bend.
You're an extension.
You're not seeing it. Anyway, so that strut is showing a little bit of a bend to it on the right-hand side where it meets that lower coupling, which is typically a place that we see it, either there or at the shaft, typically up towards the mount bushing at the top, the strut mount. So then we get into wheel setback, and I usually use for an example of setback. So this is, again, we're building that box around the car. Where are our wheels in relationship to each other? Are they in symmetry all the way around the car? And if we have one wheel that's pushed back, why is it pushed back? Is it because there's a component that's damaged? Is it because the body is damaged? Or moved? Is it a subframe that is damaged or moved? All of these things we want to be able to identify through these angles. And I use for an example with this one, so many times, and it probably happens in most shops on a regular basis. I had, Greg, you want to switch over? I had my son was had his car parked in the driveway. He's a little bit ahead of me. I have my car sitting towards down the driveway a little bit, and I have my left wheel turned outwards. So it's sticking out of the fender a few inches. Well, he decides to back down the driveway and clip my tire. And it scratches the bumper cover a little bit. At the time, the company that I worked for was a company car. They said, take it to the body shop to get it fixed. Went to the body shop to get a little scratch in the bumper cover fixed where he had made kind of a scraping along the side of that bumper cover. When I picked the car up after having the bumper cover refinished, I noticed that the car didn't handle right. Didn't seem to go through corners right. The steering wheel wasn't really perfectly centered. We took it to a repair shop to find out that the setback was off on that side. And in that impact, though it showed no damage anywhere else, it actually waffled the back corner of the control arm, bending that control arm and moving that wheel out of position and causing a problem down the line that required me to have to go back. And the challenge with it is it's an insurance claim that sometimes we can't go back and just refix it the second time. So we need to be able to identify that early on or in the process to make sure that we're fully covered for it. And I think wheel setback is one of those other angles that as we go through the chart here a little bit of what those angles can mean, it will it overlays to identify or to reduce down some of the other angles with it.
Oh, you're good.
Okay. All right. So and then we're into that maximum steer lock to lock. Again, this is where we're checking for things like did our rack jump a tooth? So were we in the middle of a steer when we actually made impact in the collision and it jumped a tooth in the rack or it damaged the inside of the rack? Steering stops being out of whack or being bent or broken, damaged pitman arms, and that gearbox having that shift in it is going to identify it. And again, as I talk about documenting before, we're talking about documenting those readings so that we have the ability to share with the insurance company, this is why we need to go replace the steering box, or this is why we need to replace the steering rack, because of the way the numbers come out in this report. So, went the wrong button. So, and then we have that turning angle on turns. And I think, Justin, you talked about that fantastically.
Sure. Yeah, and this is one of those that is interesting, just as an industry, kind of the guideline that we have for that is that when we are in a turn, our inside wheel will turn 2 degrees further than the outside wheel, generally speaking. And so we wind up measuring that at kind of an industry standard of a 20-degree turn in either direction. And the aligner will walk you through that. Some vehicles do have the specifications from the manufacturers right in the system, but even when you don't have the specifications, just knowing what you're kind of looking for there helps out a whole lot too.
Yep. Yeah, and that 2-degree difference is really, if you're just looking at the raw numbers, you're looking for that 2-degree difference from one side to the other to make sure that we're in the right place. Mm-hmm. If we don't see that, again, that's another indicator that we have something else that's bent. One of the big challenges that I see in the industry a lot is people diagnose a steering knuckle as being the problem, but they really don't know why the steering knuckle was the problem, and they're not documenting why the steering knuckle was the problem. They're just kind of poking and hoping at it, that we're just going to replace that part, and that might mean that we're going to go send that car back 3 times to the alignment shop, replacing a different part each time. And one of the things that we hear a lot from the collision space, even in the repair space, is people aren't going to pay for all of this, or especially insurance companies aren't going to pay for all of these, for doing the extra readings and that sort of thing. And the reality is, every time we talk to an insurance company about this particular topic, they're usually extremely excited to have shops doing this and providing them this information, because either it's the subrogation issue that they want to address, or it is the fact that I don't want to have to waste time and money going back and forth with this car. And one of the challenges that we see in the industry is that the rental car part of the business, I think the number now is $9 million a day that the rental car industry makes, or that the insurance companies pay the rental car industry in rental cars for replacement vehicles. So if we put ourselves in the insurance company's shoes, if I can shave a day off of that time going back, that cycle time, get that car back to that customer, that's a significant savings for the insurance company. And if we're not having an adjuster go out 2 or 3 times, again, a significant savings for the insurance company, as well as a productivity boost for the shop itself. All right. So those symmetry angles, so it's very similar to our thrust angle, and our wheel offsets, where we have our axles pointing. This is, again, going to create some drivability issues, but we see it more in the collision space, as this indicates that there is a problem, usually with a subframe that's misaligned, or a unibody that's been damaged one way or another. So that steering axis inclination, this is, again, that critical angle to make sure that we're getting the right, or getting the diagnostic angles to help us with that. And I think I'm going to blow through a couple of these for you guys. Other than this, where we got some things that are going to be indicated when it's greater than a 5 degree, or 1.5 degree, cross SAI. So when we talk about cross numbers, that's really comparing left side to right side. Where are those numbers at? They're typically not going to be exactly the same, but they're going to be within that 1.5 degrees of it.
Right, and that's built into some of the way we adjust them, right? When you think about the adjustments for camber and caster on a vehicle that has triangle shaped control arms, for instance, right? If I'm making adjustments with the eccentrics or the slots on either side of that, then there's gonna be some amount of move and change. When you're thinking about, you're looking at the front of that vehicle, that steering axis inclination, again, steering axis, the 2 pivot points, upper and lower, there's certain adjustments that I'm gonna make to my alignment that are sometimes gonna move that stuff around a little bit like that. And that's why we do allow for, as an industry, a 1.5 degree variation side to side is considered pretty normal. So, yeah, absolutely.
All right. So that SAI plus camber now starts to identify a few more things. So we got in there bent knuckles, bent struts, bent ball joint studs. So the shaft itself within the ball joint, which is typically very difficult or maybe even impossible to see, we're actually getting the numbers. And again, we're documenting those numbers so that we can speak to the insurance company and show them why we're seeing that.
One of the ways that SAI works, and if I'll get right here with you, one of I think the easiest way to understand how that works as a diagnostic angle is if I think about the steering axis on the 2 sides, right? That's that same line as my caster from the side, and I'm looking at from the front, it's leaning like this. It's created by 2 pivot points, right? And if it's wrong, the only way it's wrong is that one of those 2 pivot points is moved. That's what it comes down to. So when we think about diagnosing that, if I've got a front situation on a vehicle like this, and one of my SAIs is not as steep as the other, right? Or it's not leaned in as far as the other. Something had to happen. Now, either my upper pivot point would have moved further out, which is kind of an unusual situation on a vehicle, although I'm sure you guys in the collision world have seen that. More possible, easy to imagine, is that lower pivot point coming in somehow. And we saw in that visual of it earlier, that lower control arm. If you think about that, that's quick to see. SAI helps us diagnose certain structural components, such as a lower control arm, because sure enough, if I get bent, I ride this thing up on a curb or something, bend that control arm up like this, it's going to pull that lower pivot point in, and it changes that angle. And again, so as long as it's within 1.5 degrees, it's considered normal, but you get further than that, it's going to make a change. Included angle and SAI are both camber-related diagnostic angles, and they work, each one of those is going to work to isolate different types of components on that front suspension.
And this is not just, we talk a lot about the collision space because that's typically when they get bent and damaged. But even our independent repair shops are running into this on a daily basis because, let's face it, there's potholes everywhere. There's, we have some roads that might not be as smooth as silk, and curbs that jump up at you in the grocery store, or people that pull out on you, and you're making a quick evasive adjustment and popping over a curb. In my hometown, we have a Taco Bell that nobody can seem to go through the drive-through without damaging some right sides. So I know there's a couple of shops that are regularly fixing bent control arms because of Taco Bell. So it's really an impact to the entire industry. Yep. So again, there's diagnostic measurements. Just want to reiterate those that we're looking at: that steering axis inclination, included angle, setback, turning angle, max steer angles, and this symmetry. And, you know, obviously we here, Hunter, we have the system is in place to be able to do that, and that sort of thing. Any of your alignment equipment should be able to do this. These are the angles that are that are available to a technician to identify that something's bent, that's very often gets overlooked and doesn't actually get measured enough to be able to see that it is, that doesn't get measured, really, doesn't get used or measured to make sure that it is, that we're doing the best for our customers. So, all right. Okay. So there's, we're run through a couple scenarios here where we have a camber, a left and a right, and our numbers here. Justin, you want to jump on?
Sure, so what, yeah, okay, is that gonna work? Oh, Sam, knows the numbers over here. Let's just do it like this, you're just gonna have to imagine, I'll just describe it here for you a little bit. What we have here is a scenario where you would have a known good side of a vehicle, and then a side that clearly has some troubles. Now that left-hand side, the green numbers gonna indicate that we're well within our specifications, and we can see our SAI and IA numbers. When we have that kind of a scenario, then we're going to believe that this side is a known good side. Apparently some kind of damage or something is taking place over here. This variation obviously gets us pointed down that way, but this is where it shows up diagnostically.
Oh, wow.
This is where it shows up diagnostically.
We're having fun backstage.
Down here at the bottom, where you can see the SAI is within 1.5 degrees side to side. But our included angle there, we've got more than a 1.5 degree variation on that. And so that raises a flag and makes a person think, huh, I wonder what could be happening here. So the diagnostic charts that Ron mentioned earlier are, again, it's an industry standardized thing. I don't know that it's something we came up with, but there's lots of ways you can see it out there, where it points to things like, the chart will say, okay, what is camber doing on the known bad side? Is it positive or negative of where it's supposed to be? What then is my SAI doing? Once again, is it okay? Is it positive or negative where it's supposed to be? And then include angle. That series of options, based upon what the vehicle is doing right now in this chart and what suspension style it has, points you really quickly to things like a bent control arm, a bent knuckle, a bent ball joint, perhaps a ball joint stud, those kinds of things. The strut, cradle shift positioning. Lots of powerful things there that we can use for that. But I'm going to show you maybe one more quick example of that here on the screen. Just walking you through here the idea that first one, camber, is a problem. We're okay, that SAI is described, right? And in that particular scenario, we are able to diagnose and point that based on our chart, we've got our chart in hand, then it would show us on that strut type of a suspension that based upon that data, we're going to be looking for something wrong with that strut. Just like on the strut tube here, we can see it kind of magned up like that, right? So when I think I've got a bent strut, we're going to look for the common points of failure for those struts, right? As Steve was mentioning before, where that strut to knuckle mount occurs, oftentimes you're going to see it bent there. You guys are the ones who are going to see these things more traditionally and know exactly those points of failure. But that's the kind of thing that it winds up doing, is it gets you pointed in the right direction, quickly making that diagnostic process a lot more efficient.
Absolutely. And I just wanted to kind of reference, you guys should have this in your handout section. The chart that we've been talking about is this chart here. Do it this way. That is showing the differences, basically where the positive and negative are for each angles. And then actually in different segments are the different types of suspension systems with it. So it's a reference chart for you to look at the numbers and be able to identify, here's what's bent from it. So you should have that in your hand.
And at first glance, that can be a little bit daunting sometimes if you're not familiar with exactly what's going on. that is certainly one in our level 3 alignment class that we spend a good amount of time going through exercises to make sense of that. So SAI and included angle are two angles used to identify camber-related problems and what those components could be that are causing them. Great.
So actually.
I just got
All right,
so-
pass it as far as you want.
This is another one, a great opportunity to be able to show a steering knuckle and be able to take some measurements to identify that steering knuckle being bent. So when we have our alignment readings that are showing that that we potentially have a steering knuckle bent, now we're identifying ourselves to be able to.
I don't think they can hear you. Can you check to see if Ron can hear you?
Ron,
I
can you
can-
hear me?
I can hear you not real well, but I can hear you.
Your mic just went really wacky.
Gotcha.
I think he has to move it closer or
Yeah, it's really scratchy suddenly.
Okay.
Just have him talk for a second. I'm gonna go get you a different battery.
Okay.
I have a question while he's doing that,
Oh, good, yeah, fire up.
or more a comment. So if you're if you're attending this class and you're taking your alignments out, you might want to bring that chart to the shop, because I know when I go around the shops and talk to them about SAI and what's bent in that chart, they've never seen it before. So most alignment shops don't even know about that. It's something good that you might want to look at. My old shop called me and said, drive this car, something's wrong with it, we can't figure it out. So I drove it. I said, well, did you check the SAI? And they, well, no, we didn't. I said, well, you should, because something's wrong with it. So they checked it. It was a body shop sent them the alignment. So I'm like, well, what did they do to it? They said, well, they put a spindle on it. And I said, well, something's not right. They found out that it was a hybrid car and it was a half-year change in the spindle, and they got the spindle from a used car part place, and it was the wrong spindle, and you could feel it driving. It was like three-wheeling. Put the right spindle on it and fixed it. But most don't know about that chart or SAI or what's bent. Just comment.
And Specialty Products Company has a fantastic magnet version of it that I'm a big fan of. If you Google SAI alignment diagnostic chart and go to just even the images, you'll find a picture of it from Specialty Products Company, and it is a magnet, and I think it's like $8. It's not a big deal, but it's a great way to just slap one of those up on the side of your alignment machine or maybe on your toolbox. And yeah, it can be very helpful.
Thank you for that feedback, Ron. And that's one of the things that with this, we want to make sure that if you're doing it in-house, you take advantage of all of the tools that are available to you in-house. But if you're not doing it in-house, that you're actually meeting with your provider to make sure that they are, that they have all the tools that they need to be able to give you the right information. Because if they send you the car back with that something isn't right, without all of that data, it's very, very hard for you to be able to diagnose that and be able to then sell it to the, or have the insurance company pay for that repair when you have no documentation, nothing to kind of back up what you're saying is the problem. So used parts, one of the things that with suspension parts, it's not as much of a factor. Not as much of a factor with it, but what we have been seeing across the board with a lot of the used parts is that they are programmed to the vehicle. So if they're any kind of electronic part, headlight assembly, that sort of thing, they're coded to the vehicle. And in a lot of the cases, they cannot be coded to a new VIN number. Whatever their original VIN number that they were put to, they can't get changed after that. So if you've got a component that has, a stability control component that is a part of the strut assembly, and you want to get a used one, it's entirely possible that may need programming, and it may not be able to be reprogrammed to that VIN number, and then that car kind of rejects it as not a viable product, or a viable piece to be in its operation.
So when you say rejects it, it was set a code or just wouldn't drive right?
Could do both. In most cases, it will set a Christmas tree of lights up. Because all of these systems are so integrated that you've got something that's got years ago. It used to happen with people put aftermarket shocks in a GM vehicle that had the electrostatic fluid in it. And you'd end up with a stability control light, where nowadays, if you've got a stability control light, you also have usually an ABS light, an ADAS light, and potentially a check engine light with it. There are some manufacturers that it just will not, so you might have like an air ride suspension light on, or the air ride suspension just won't work correctly. And it'll constantly be hunting for where it needs to go.
Thank you.
Yep.
Thank you.
All right, so that rear ball joint, so this kind of depicts that ball joint being bent, and you know, in today's world, I think the majority of our ball joint still is pretty solid, but I've seen a couple of these where it has still bent that shaft, especially right at the top of the ball. But usually the control arm is one of those first places to bend or change that ball joint location. No matter how it happens, if the ball joint location changes, it alters all of our geometry of the vehicle. And that could be affecting our SAI, it could be affecting our camber, it could be affecting our setback, it could be affecting any one of those numbers by having that misplacement. All right. So this is another one where we've got our camber, you know, getting to Justin's point, we got one side that seems to be pretty solid. Our right side is off by a significant amount of degrees. So when we look at this, you know, our included angle is okay. Our SAI is dropped significantly off, and our camber is significantly higher. So this is indicative of when we have that lower control arm problem. So typically, and then that's where I like to overlay that wheel offset. We're typically going to see that in that same scenario as well, that our wheel offset is either set backwards or set forwards, depending on what it is. And when we talk about wheel setback, again, we want to consider the entire vehicle, and is it just the front suspension, or are we looking at the rear suspension as well? Because very regularly we're seeing that that rear suspension gets impacted in the accident or in whatever operation it is. All right. So bend control arm. So probably several of you maybe don't have that brand of a frame machine, but have probably been there doing those kind of dimensions when somebody says, hey, you know, something's bent, you got to go figure it out. If you want to make your life a whole lot easier, to Ron's point, sharing that chart with them, as well as, you know, helping them understand I need to have those additional angles, helps you be able to bring that car back into the shop, be able to identify what is bent, and not be replacing parts in a you know, in a part swapper kind of mentality. All right, so in this one, we got our camber is at again, our left side is good, our right side's out of whack. Apparently we are beating the stuffings out of the right side of this car. So our SAI is positive a couple of degrees. And our included angle, again, that's our angle from straight up and down to the angle of the wheel, is okay. No, we're gonna jump back to the presentation, sorry. So with that one, our SAI is high. We're going to look for the problem at the top of the top of the assembly. So do we have a strut that is damaged at the very top of it? You know, can we see the spring being distorted as it heads up, or is it a strut mount area? You know, the left side of the right side. Strut mount assembly, the unibody structure,
Bent upper control arm.
Bent upper control arm, if we're in a control arm situation, right? So there's a whole host of things that we're looking for. So again, we're not chasing all around the car trying to figure, well, where do we start from square one? We actually know a little bit closer about where we would go right off the bat. So, you know, so, and again, you guys, many of you are probably very familiar with making these measurements across to verify, your strut mounts at the top. Is the tower in the right place, or did the tower get impacted in a collision or at some point in its life? So these are some measurements that are kind of rudimentary in today's world, where in most cases you're going to use your body measurement systems to go into your body mounts to make sure that tower is in the right place. And this might be one of those things, again, if we've already repaired the car and we've now taken it down the street to the alignment machine or to the alignment shop to go on the machine, now we're finding out that we missed something in our estimate and our front horn got bent in some way, shape, or form, and we might end up having a total vehicle here. All right, so we get into some camber specs. So camber is positive on one side, negative on the other side, or
And equally off.
Equally
spec.
off,
Right,
yep.
right.
And SAI is off on the right side, and again, our included angle is okay. So you want to jump into this?
Well, yeah, when you've got that kind of symmetry side to side on the camber and they're both out of spec like that, then what you're probably dealing with is a shifted cradle of some sort. I know that cradle shift adjustments are probably all of our favorite version of them, right? But you think about that lower control arm typically attached to that cradle assembly, and it is, since it's attached to it, if it gets shifted one way or the other, it's making those SAIs move kind of like this as well, right? So that's what you would find in that kind of circumstance there. Again, it shows up on the little diagnostic chart, very helpful stuff for you.
And this is one of those things too, like on the repair side of the business, a lot of the cases anymore, when we're replacing an engine and transmission, we're actually lowering that entire assembly down, subframe and all, out of the car. And there is, in most vehicles, there is a drift pin adjustment. Again, in a lot of the aligners, the procedure is actually in the aligner to tell you. So like in this case, a lot of times this will come up with a message to say, that there is that the subframe is out of alignment, and it will actually have a procedure to center that process or center that subframe. In most cases, it's cracking the bolts loose and putting a drift pin up into a hole or a pry bar and lining up some body mounts and subframe mounts to make sure that it is aligned properly underneath the car. But it's one of those things where I think even in a lot of our collision repairs as well, we're doing the exact same thing. And in many cases, especially with rear subframes, I see that a lot, where I go into a shop and they were redoing a quarter panel and had the entire rear subframe out of the car. And they just slapped it back up in there and did not center that or align that properly underneath it. So when we have suspension components that are attached to the subframe on one end and the body on another end, it is critically important that the subframes get identified if they're out of alignment, and then we get that into alignment in the process. Or maybe even find that in the impact that the subframe got damaged because it is in alignment, but my rear camber or my rear toe is still out of specs. We're utilizing those numbers to say, hey, Mr. Insurance Company, we need to replace the subframe on here where it's typically not going to be super visible damage. Maybe once you get it all the way out, you can look at it on the ground and see that it's wrinkled or it's bent in a corner or two. But it's one of those ones that's a little bit harder to diagnose with the naked eye, where the equipment is going to help us be able to identify what's going on with it. Great, you want to come back over?
Weird, it is, it's not full after, we got about 47 minutes left. We're gonna start taking these movements.
Oh, yes.
Yeah.
So,
Okay.
so this is really what we're talking about with cradle shift. So kind of what we're seeing, a cartoon version of what that cradle shift looks like in those previous numbers, how that actually relates to the wheels, and then that alignment procedure. So in this one is, that one's a Chrysler product there. It looks like that drift that's going to align it. Typically in the collision space, we hear it. You can hear when there's a cradle issue, because usually that first bolt comes out and you hear a snap across the shop. That it's a problem. So, all right. So we got setback. I think we've touched into that.
Yeah.
good point in time. So we'll jump through a couple of these things. Setback is not only going to affect our alignment of our wheels, but it will also affect our caster of where that wheel position is. So if we're set forward or set back, it's going to alter that angle of caster and that forward and rear pitch of it. So, this one is great. So we got our left side is at -5 degrees. Our right side is at positive 4.2. So this is showing us that our strut tower is too far forward, is the lower control arm too far back. This is where we're going to use that kind of that overlay of our wheel setback. Is it that our wheel is pushed back in there, or our subframe or our strut tower is the problem? So very unlikely that our strut tower is moved that much where it's not going to affect included angle. So, and this is obviously an old school picture. We don't use
That is
this
historical documentation right there.
but it's a great depiction of that setback and what it looks like in the fender. And this is an extreme case. Very rarely are we going to see that in today's car, that it is that extreme without being able to see that control arm is visibly waffled underneath it. But in today's cars, our tolerances are much tighter. So we're actually seeing that as almost not visible to the naked eye and needing to have measurements to be able to see it. So just some examples of bent control arms. Is in this case a replaceable bent ball joint that we can identify through it. All right, and then we got our steering turn. So this is how we look at the machine, and we're going to jump over to the machine here in a little bit to show us that setback and how our wheel track is on the vehicle. So we'll jump through. This is through a couple of these. This is really this is showing that GM body setup where we've got the drift pin. That is still today. This is a little bit older. There's a lot of older cars on there that aren't really being produced anymore. But still today, many of the cars use the exact same procedure to realign that cradle. All right, let's jump over. What we want to do is really going to show you what this looks like. So we've gone through a lot of the numbers, and hopefully we've shown you how there's a lot of value to those numbers and how they can provide you a lot of information about your customer's vehicle and help you be able to make the right repair and know what's bent, what's damaged, so that we're adjusting for it appropriately. The next challenge that I hear from a lot of places is that, well, that's great and we can get all of that stuff, but how do I put it in place? Like, how do I make this happen within my shop? So we wanted to take a little bit of time in this and really kind of go into that part of it with what does this look like in the shop and how we would identify it. So we've got a car here. Greg, you want to switch over to the other camera there? So we've got a car here that has been rolled and compensated with it, and what where are we at? So you want to run the additional measurement?
Sure, yeah, absolutely.
Yep.
Let me know when you want the full screen.
Okay, great. So yeah, those of you at home, I think you can kind of see at least from where you're at what's going on here. We're just looking at our normal bar graphs. There you see them. And this is a lot of the data that most of your alignment technicians are working with, right? We've got front axis, we've got rear axis stuff. We've got information, but again, that's all they're seeing. I want you to glance at the bottom of the screen. You can see where it says show measurements down here at the bottom, second option from the left. Clicking on there, we've got two sets of measurements. Now this is our primary measurements. Once again, this is all the stuff that we're used to seeing, and that's really all there is to it. But if you look at the bottom of the screen, on what we refer to internally here as K3, that's my third soft key over from the left. Here you can see it says K4 is another option here, but K3 says show secondary measurements. Now when I click on that, this is where that diagnostic stuff shows up. Now, if you are currently doing your caster sweep, including brake pedal depressor, if you're using that brake pedal depressor to do your caster sweep normally, then it is actually by default already measuring your steering axis inclination and your included angle. Those two are already there for you. And that's why we actually see the included angle populating all the way up here. But a lot of blank spaces left on that screen, a lot of data, in other words, that more than likely at your shop has been underutilized because people simply did not know it was an opportunity. One thing I'd like to go ahead and see here is that let's just look at this stage together, right? 3.27 degrees in a big bold red, and that weirds some people out. But that already tells me that I'm not telling the truth on this car when my steer head is not pointing straight ahead. Because when a car is not pointing straight, when my front tires aren't following that thrust line, when it makes some kind of a turn, it impacts other angles as well. So my camber data is not necessarily right. My total toe numbers aren't necessarily right, and that kind of stuff going on for you there. So just so you know what's happening there. So we'll go back to that screen, and I'm going to just change that steer head by turning my wheel a little bit. I can do that at the steering wheel. I can do it at the wheel inside the car, whatever I would like to do. But we'll get that back to telling the truth. So that 0 steer head, that means that my front tires are following the thrust line. That means that they are pointing in the direction that they will be going when the vehicle is in motion. 0.02, those are hundredths of a degree. So that is certainly sufficient enough for us to make sense of that. But so once again, I start then wondering, what on earth are all these blanks? What else can I do with that? So these are the angles we've already discussed here at length for you, and I'm going to show you how we can capture those measurements, okay? Right now, with whatever alignment equipment you have at home. But here in the Hunter alignment machine, here's where I'm going to do it. At the bottom of my screen down here where you see the purpley pink cursor, these are the different rows of options for my buttons down here, my keys, my soft keys we call them. I'm going to hit the magnifying glass just to show you quite a few things going on down here, but what we're going to dive into is called make additional measurements. So I'm going to select that. And I'm given a menu here of all kinds of good stuff. But if you start reading through that list, you're going to realize like, oh my goodness, there's a lot of collision alignment related issues down here. And what we're going to do is just start working at the top and make our way down. Okay. So that very first option here, just to start exploring it, says frame angle. I'm not worried about frame angle on this vehicle because we're talking about at the top, you can see clearly that's a pickup truck. We've got a Toyota Camry here. But frame angle deals with our caster measurements on vehicles. Turns out if a vehicle is elevated in the rear or lower down, that caster, imagine that's that caster, it moves with that doggone frame. There's a screen on your alignment machine that if you're doing alignment work, your technicians are skipping that screen sometimes because they simply don't understand what it's doing. But back in here, my first option is going to say ride height. Now the ride height of the vehicle is an indicator of whether things are going well or not, of course. And we've got a quick and easy way to measure it, don't we, Steve? We do, yeah. So we're going to select that and say, okay, down at the bottom right of it. And we will go right into our ride height here.
When I pitched the right button.
So these are, we can do it on the cameras, whichever one you want. So these are the Hunter Live Right Height targets. Now, if you have a Hunter Hawkeye Elite alignment machine, again, whatever you're using is fine. This is just what we have to offer. And these come standard equipment on the Hunter Hawkeye Elite alignment. So if you have this type of a target on your wheel, then these are probably hiding in your alignment machine somewhere, okay? They do relate to those BMW alignments we were talking about a little bit earlier, the sandbags and all the weights and that kind of stuff. Not overly complicated. We're just going to stick them on the car directly above the spindle at the top of our wheel well here. Here, you take one. I'm going to put one on just for the good times. I'm going to take that one. Okay, great. You go that side. Fantastic. I've just got some double-sided sticky tape on here because that turns out is really friendly for cars. If we were using magnets or something of some sort, we might be more prone to create a little bit of chaos. So we're just going to stick those, like I said, above the spindle, whatever in the front of the vehicle. And you can see on the alignment machine that it has started to populate those ride heights. Here we see 15.5 inches, 15.2, etc. Shows here in the middle, what is it kind of comparing side to side. Now, where that measurement is right, doing that number in the middle is comparing the two sides. Now, I love this moment for you guys at home. Here where it says no target, and it's saying it can't quite see this right rear target, all I've got to do is click here on view targets and make sense of it. Was it the mirror? Okay, so sure enough, the side view mirror, I just like you guys to see this. This is real world stuff here. Nothing staged for you. When I click on view targets,
we could see that I've got my 6 little dots here and here and here, but this one is somehow not quite seeing those dots. And so on the vehicle right here, Steve, through his fantastic diagnostic procedures, is going to pull that mirror out of the way. Sure enough, there we go.
So sorry.
It's funny how the real world does those things too, right? So anyway, now we've got all the data on our screen here. We can make sense of what our ride height condition is. Now they tell us that about 5/8 of an inch difference side to side is where you start saying, something's kind of fishy on this thing. And all of our numbers are looking great. That maximum 3/10 of an inch, no problem at all. So I hit OK there. We have measured that ride height. And when I go to my secondary measurement screen, again, back down here at the bottom, suddenly we have populated ride height front and rear. Okay. Let's just keep moving down our list though, right here, magnifying glass at the bottom, make additional measurements. Let's find something else about this car. Let's go to our symmetry measurements. We're just going to skip a couple of things here to kind of stick with the basics. We'll go to virtual view, symmetry, wheelbase, and track. Let's go there. This is going to be a good time for you. Watch what's going to happen here. All I had to do was I only had to click about 2 buttons there. And instantly, we've got a lot of these symmetry measurements for that frame and what's going on. Now, you may not be familiar with the way the Hunter Hawkeye lead aligner works, but what it did with these targets was locate the spindle, the center of the spindle on each of these axles. And that's how it's able to give us that information, the information from that front and rear spindle all real quickly. It didn't have to do any other calculating, it already knew where that stuff was. But through here, we can see our front and rear setback initially, showing us what's going on those 2 sides. And in this case, ever so slightly, the right wheel is trailing the left just a little bit, right? Now, some people would say, yeah, but I want to see that in distances. Now, in the collision world, correct me if I'm wrong, Steve, are we more about angles or distances? A little bit of both sometimes? A little bit of both. A little bit of both. And so we can actually see that stuff as distances, but we'll hold tight on that for the moment. I hit OK there, and we're going to find that we go back to those or we go to our, let's look at that measurement screen again, because I like to keep seeing what we are making happen. So we're going right through here to our measurements, those secondary measurements, and there our setback is also showing up here for the rear and up here on the front. Again, just continuing to populate data. Now, this is important stuff because if you think back to that printout that we talked about earlier on for you, where on the one you just have the traditional bar graphs. Here, we are creating a comprehensive printout of all these different things happening on that vehicle. They're going to go and show good or bad, right? But at least you'll have that data. Let's take another measurement. Once again, make additional measurements. Now, by the way, this is a great time to pause and say this. What we are doing in this moment is manually and intentionally making these different measurements. Now, on the newest version of our software, we have the opportunity to do what we call a blueprint alignment process. Correct? You want to mention something about that?
Yeah. So, and Justin's 100% right. It's so the newer system, we're going to go through these individually, so that if you've got a car in the shop today, on any of our software, or if it's just a matter of you add another shop that has another kind of alignment system, these are the measurements we want you to ask them to put. To produce for you so that you can diagnose what's going on.
Right.
We've kind of taken that next step and gone to say, hey, how can we make this even easier? And we have streamlined this whole process to, like Justin said, to blueprinting. So we're putting the targets on the car, we're rolling the car forward, we're making it a couple caster sweeps and getting all of this information in one shot. About a 4.5 minute process. From start to finish. And that's where when we talk about kind of supercharging the bay, if you've got the alignment equipment in-house, we're doing that as that car is coming into the shop for the first time. So we're coming in for the estimate and it's got that left front or the right front hit on it. We're going to be doing that check right off the bat. So we're identifying the bent control arm, the bent strut at the same time that we're ordering the hood and the fender. We're also ordering the control arm or the strut or whatever other components we have to speed up that process. What we see for the collision space is that reduces cycle time by days in some cases.
And so we'll touch on that a little bit more here in a little bit, but I just wanted to, I know that some of you guys at home might be thinking to yourselves like, oh my goodness, why does it have to keep clicking so many different things one after the other? We just want you to understand that you can individually select any of these things. Say you were just suspicious about ride height. Great, just do ride height.
but we're just showing you that option on the menu. Okay, absolutely. I just want to be clear about how that's going down for you, okay? So we've looked at our symmetry, wheelbase, and track width data that is showing up in there. And I want to go back and look at that image one more time for you. Let's go back to the screenshot here, where I showed you with the front setback and the rear setback. Yeah, you can leave it on the screen just like that. By pressing the next value button down here at the bottom, we're going to cycle through other bits of information. Check this out. There's my axle offset, showing where my front and rear axles compare to each other. So in this case, tracking beautifully. Here's my left and right lateral offset, showing, again, as individuals, what's going on. And then it needs just a hair more information, okay? Do we have a tape measure close by?
Yep.
Fantastic. So what it's going to ask us for here is that wheel width on this vehicle. And so we can use a tape measure, just pass it through that wheel real quick and find out. In this instance, I'm looking at, these are 8.5-inch rims, roughly. And so I'm going to put in 8.5 on the front and rear. Of course, if you have staggered sizes, you would want to have them different for the rear, whatever. You want to be intentional with that. But we're going to tell it that we've got those 8.5-inch rims. And then it wants to know a very specific distance between part of the face of this target and where it is the rim lip. And this is so it can do some calculations about other things going on. In this case, we're about 5 3/4. So we're just going to put 5 3/4 inches down here. Hit OK. And that allows me to get a little more stuff going on in here, including all of that wheelbase data and my track width. The track width is why I need to know the width of those wheels. But that, again, very powerful way to do it, just in terms of a visual representation. That kind of a screen helps for your technicians. You can hit print screen at any point in time if you're trying to show stuff to a customer or an adjuster or anybody else like that as well, right? We can even rotate around the angles of that vehicle to try to make sense of what we're trying to really explain what's happening there, right? So lots of neat ways to see that, however makes sense for you and your team. So that was what, yes, please.
So one of the other things that is important there is in a lot of these is both the.
Okay.
So the most important thing there is we have our print functions, so that we can actually print this out and have it as part of our documentation that we're providing to the insurance company, or that we're providing to the customer, or again, if you're the one that is subletting out to somebody else, this is what you should be asking for them to send back to you, so that you have the documentation to identify, one, diagnose what's wrong with it, but two, support that case as to why you need to replace it. So all of what we're showing here is all printable to be added to that same report.
Absolutely. So let's go back to our remeasurement, that secondary measurement screen, and just kind of see how things are looking, right? As we continue to populate all of that good, valuable data right here, right there. So lots of different things going on there. Now we've got that wheelbase and track width populated, lots of good stuff. We're still lacking a few things though. I see all these dots. That is my cross turn, my turning angle. We talked about that toe out on turns, the acting angle stuff when I'm turning. That one we haven't quite done yet. We're going to let Steve cut loose on that. We've got the maximum steer left and right. Those are still blank as well. And whether or not you know it or believe it, there is a third screen yet to come. Body stuff. We can talk about that, right? Right. Some of those body images. Steve, why don't you show them the cross turning stuff?
Yeah, all right, so we're gonna jump down into those additional measurements. And we're gonna get out onto our turnout on turns and our max steer. So let's start with our turnout on turns. We're gonna say okay to that one.
Yeah,
Yeah, if you wanna see it, then I'll say it here.
sure.
So now Justin's gonna steer our wheels, and it's gonna actually give us an indicator so that he can watch that turn to get to the place where the indicator is gonna actually start appearing here.
Now this one doesn't have
Okay.
specification.
So we're just gonna go to around that 23 mark
Yeah.
and be able to identify that that's where it's at. Now the machine's automatically gonna take that reading and flash, and up on the top, it's asking us here to rotate the wheel in the opposite direction. So it's giving us the instructions all the way along, we're hitting that, and now it's gonna ask us to center the steering wheel.
That's me. I'll get out of the way.
So now we've done our our turning angle difference has now been documented within it. So we've got rid of a few more dots to give us a little bit more information of what we're doing. And we're just gonna jump back in there and make additional measurements. And let's go into our maximum steer. So one of the things that we are gonna do in these measurements, you wanna jump to the camera? The one thing that I want to show you with this, here is, we're gonna add on these targets that are here. These are what we call wide angle targets. So the nice thing is they just magnetize onto the end of our targets, but if we did not have these, as we turn this wheel all the way to one direction or another, we're gonna lose the target. We're not gonna be able, the cameras here on the alignment machine aren't gonna be able to see it. So we put those extenders on it to allow it to swing all the way through its entire rotation.
And that comes as a result of our targets being lightweight and small and low profile, so they don't get in the way when you're doing a lot of other stuff. On these very specific, all the way turning one way or another kind of scenarios, yeah, we can stick on those extenders there a little bit. So we're going to measure it first. It says to steer to the left. It says steer the wheels as directed, steer without pausing until the wheels lock and hold. So I'm just going to turn this thing all the way over to the left and hold it up against that steering lock position. Around 35 degrees or so off something. There we go. And then it takes that reading once it sees they are stabilized and says, okay, turn the other way.
Jump into us to tell us to go the other way. And it's gonna pause for a second, and it accepted it, and now it's bringing us back to straight ahead.
Now, you may or may not have noticed that we're making these measurements without the engine running. Okay? Couple of thoughts on that. By having the engine turned off, none of our targets are shifting and shaking around in there, which can happen sometimes. Because of that, gives us good stable reading on all those measurements. And that holding it in the locks always makes weird, unhappy sounds on a hydraulic power steering system. So we're not doing any abusive kind of things to that either.
Right. Yeah, it's the other side of that is that, you know, we are in most cases, both ours and several of the other brands out on the market are utilizing camera technology that are reading these targets. And when the engine is running, if that engine has been running for a period of time, the car just came in, that sort of thing, that heat can actually come up from around the car and distort the air. So if you think about looking over blacktop in the winter or in the summertime when there's heat and you're looking at that distortion, sometimes that will blow over the top of those targets and alter what the cameras are seeing and create some anomalies. So we always want to make sure that what we're doing is with the car, you know, potentially key on engine off so that we have the ability to rotate. That does have a couple caveats. So number one, a lot of the manufacturers today, it's not very easy to put a car in neutral or to have the steering wheel not lock as soon as you close the door or those sort of things. So there's many times where you may need to know that procedure to be able to put the car into a service mode or into a car wash mode, that sort of thing, to be able to roll it, to be able to do the compensation process, or to be able to, be able to grab the, make the steering wheel actually go through the turns. The other thing to think about too, if we've got a car with key on engine off, if it's for alignment purposes, if it's for reset steering angles, or if it's for ADAS calibrations, we want to look at having a good battery tender on the system. So that's not your, 60 amp or 80 amp, battery charger that jump starts the dead car. It's actually a low sine wave battery tender that allows you to keep the computers active within the car without draining the battery down. Because many of these cars, there might be 100, 120, 130, 200 computers on board one of these cars that will cause it to cause that battery to go dead and create a whole other host of problems. So we want to make sure that what we're doing no harm to any other systems and continuing to operate efficiently and effectively that way. So, all right. So, Justin, as we were doing that, he pulled up our printout. So we have our maintenance printout or our printout that we would normally see on an aligner.
Wrong one.
Hit the wrong button there.
5, thank you. Were you trying to tell me that? Okay, yeah, I wanted to mention this real fast, because just like we've been talking before, I wanted to make a printout just to show you really the difference in the things that we've done here, right? Where the printout, this initial one, is again, just all we've ever seen. If you're lucky and you're subletting to some other shop that's doing alignment work for you, if you are lucky, they're giving you a printout. You and I both know that's how that works sometimes. They say, oh no, we're good, everything's fine. This printout is just all we get, again, that basic stuff. So I wanted to compare and contrast and let you see, like we showed you in the presentation before, the real printout for this vehicle right now, in terms of the actual kind of measurements of stuff going on. We've got a good bit more data there that is going to include that wheelbase difference, the turning difference, all of that kind of stuff in there, the setback. All of that kind of information is in there as well. But there's still a couple of things that we're lacking. We're missing a couple things like body angle and body wheel setback. Okay? Those are other angles. Now, those are dealing with the body of the vehicle sitting on top of that chassis. What is it doing? And I think even in that pilot story, you were talking about the unibody being kind of shifted. That was a body situation, right? Where they didn't necessarily make any sense of that. And here, with just a few clicks of the mouse,
Oh, broke it.
look how durable these products are. You would be able to find how is that body sitting compared to that chassis. Okay, so let's do a couple of those real quick for you. I'm going to hit cancel here on our printout. Go right back in here as the computer catches up to me. We are good. Everybody's good. We're going to go back in here to make additional measurements. And I'm going to scroll all the way down to what we call our suspension body dimension audit. Okay. See if you have any specific thoughts about it in a moment.
Not right now.
Great. So suspension body dimension audit. And suspension body dimension audit is kind of one quick way to go through a lot of these key highlights of what's going on. Is that suspension doing okay compared to body? What's up? And so I'm going to select that. And let's just see what happens here for us, okay? Is that okay? If you hadn't already done it, it does ask us for the information there, you're good. As far as the rim width, once again, and where is that target sitting on the face of the wheel, no problem at all. We hit okay there again, it's giving us some real specifics. Steer the wheel straight in because it wants to be sure it's telling the truth. Other things here about an earlier version of technology that we don't have to worry about here. We're going to say ready. Here's all of my ride height data and my body offset put in there initially, okay? Body offset meaning where is that body sitting compared to the tire and the wheel, all that stuff, the chassis stuff going on there, right? And here we can see the body overhangs those wheels by maybe about ½ an inch on all the positions. That sounds about right. That's what we would maybe want to have happen. I'm going to hit okay. Here's another way, another visual representation for that. Now on this one, I'm getting to see my wheelbase, the body setback there, things that are going on, again, side to side, where are those wheels sitting compared to the body? I don't know. You guys have powerful tools in the industry already, I'm sure, in some way.
Yeah, and this is gonna be one of those things where in a lot of the cases, you might be using your actual measurement system to measure the unibody from underneath and that sort of thing, but this is another one of those like kind of double checks, let's say, make sure that the body is positioned correctly. This will also help us identify just a different view of where that rear subframe is, where that front subframe is. Are we mounted correctly on it? Is what we're delivering back to the customer exactly what we need? And where this one I think is critically important is that as we're getting into our ADAS calibrations, again, remember all of our cameras, all of our radars, they're all mounted to the body. They're not mounted to the suspension. So this gives us that representation to make sure that our body and our wheels are in complete alignment. So I have the best chance of having a good, solid calibration when I go to my next step of the process, which is to recalibrate this vehicle, recalibrate if it's dynamic or if it's static, whatever it happens to be. I now know that my wheels are in the right place, all of my reference points are right. When I'm calibrated, my cameras and radars are looking at the right place going down the road. And again, just adds more to my documentation to show either that it was right or what was wrong in the beginning. And the challenge with this one, with some of this is that if you've got a car, if you're, depending on when you're doing, if you're doing it at the end of the process, it's works perfectly. If you're trying to get numbers at the beginning of your process, this is probably one you're not gonna do. It's a great double check to make sure that we did everything right in the end. But if we were bringing this car in because it was hit in the left front, we wouldn't be able to put a sensor on that side and accurately get a good number
Yeah.
because it's a
For the
cross
body.
fan fender.
Right.
So it's one of those things that it's got its place to be used. You're probably not gonna use it every time.
Mm-hmm.
So, it adds to the package of all the information. And really what I wanna get into, what I wanna talk about that, so we went through, as Justin said, we individually went through each one of those measurements, and I wanted to make sure that we did that. So you can see all of the different measurements that are possible and capable with it. The challenge, or the opportunity then is that how can we put this into our shop and be able to operate right away? So what we want to do is, what we want to suggest is that as you're sending it down to the shop, down the street, or you're doing it in your own shop, as you have a car come in and you're writing an estimate, or you're trying to understand what's going on, doing these readings ahead of time gives you that before and after, or that before picture of what happened. And I always use, for an example, if I'm driving down the road and I'm bebopping along, listening to the tunes, and I see out of the corner of my eye a car coming through the intersection, where they got a red light, and I don't think they're gonna stop. My natural reaction is to turn my wheel to the right as they come plowing through that intersection and hit me on my left front corner and send me over to the curb. And in most cases, when I'm gonna hit that curb, my wheel is turned and I'm gonna drive my right side tire right into that curb. Maybe hop over it, that sort of thing. Typically in today's world, when that car gets towed into the shop, the insurance company only cares about the left side damage because that's what was a part of the hit. If we want to identify, if we want to make sure that we capture everything, we need to do that right off the bat and do this alignment assessment to determine, okay, not only did we have left side damage from the actual impact of the collision, but we had right side damage because of those G-forces that got driven through the tire. Maybe didn't scratch the wheel, maybe didn't bend the wheel, but damaged that tire to the point that it drove some of that extra energy into the suspension, bent a knuckle, bent a controller, bent a tie rod end, whatever it is on the right side, on the right side, as opposed to the left side where the impact was. So the sooner we can do this in the process, the more effective we are at delivering the car back to the customer, reducing our cycle time, and getting that car done right the first time with everything that it needs.
Everything you've seen us do today in terms of these additional diagnostic measurements. Yes, Steve and I have been yabbering on about it, and it takes a while to kind of get through showing it in that kind of time. But I'd say you can go from a vehicle on the alignment machine to all of those comprehensive measurements completed within 7 minutes, maybe.
It's a very streamlined process.
Yeah.
Where Justin, we did the steering, he turned the wheels, and he did the 20-degree sweep, and then we did the stops, going all the way to stops as two separate measurements.
Mm-hmm.
In the streamlined process, that's one continual process.
Yep.
It's holding at 20 degrees, it's moving all the way to steering stops, and then go to the other side and do the same thing. So we're looking for ways on how we can make it more efficient for a technician to be able to get those numbers. But the most critical piece is that we get those numbers and make that the determination of what is bent, what is damaged right off the bat.
It's all about getting good information as efficiently as possible.
And on a regular basis, I was on a call 2 days ago with a pretty prominent insurance company that we will be actually talking about this with their adjusters, because they're seeing such a value in being able to process a car quickly. The other side of that is we had a question early on about alignments and ADAS calibrations. If we have in our process that the minute a car comes in, it goes on the alignment rack to verify that the wheels are right, or what damage can be done to the suspension. Let's say there is no damage to the suspension. It was a light hit, it was a bumper cover, we got it. It's all good. If the OEM procedure requires that the alignment be verified before calibrations are done, we're done. We've already got it. It's already done. We're ready to go paint the bumper cover, do the repair work, and then go right into the calibration right afterwards, because we have documentation showing that the wheels were in the right place already. But if there is been some components and items, we're able to order them again, like I said before. When we're ordering the hood, the bumper cover, and paint, and everything else we need, we're also ordering the control arm or the strut or the knuckle that we need, so that we're not having to move this car in and out multiple times or sending it to the shop down the street. So, with that, I think we're really kind of wrapping up to the end. I want to open it up to anybody if there's any questions or anything we can address for you as we're here.
And you can ask questions about these specific types of procedures or angles or measurements, or if you've got any questions about us and the people that we can send your way to help, if you've got questions, anything about that, we're here to help.
So Ron, were you able to, are you on there?
I'm still on. Yeah. I want to thank you for all the detailed work and dedication to do this for us on a Saturday, on a Saturday morning. We appreciate that. I want to mention to everybody here, we have a couple of events coming up, the Northwest ATE in Seattle, March 27 to 29, the TST event in Terrytown, New York, March 28th this year, and then our tools event, Mid-Atlantic Auto Care Tools event, which we will be doing the Hunter thing again there, and that'll be April 29th to May 3rd. Thank you, everyone. Thank you, guys. You did a great job. I don't know if there's any questions in the chat. If anybody has any you want to dump in there, I'm looking. So to do that whole report, does your competition do that? Do they have all them? You don't know? Okay.
The angles are kind of industry standard angles,
Right.
so
Right.
the assumption would be that they have them somewhere, somehow within their system.
Yeah, those should all be attainable, through whomever. We don't know how organized or simple it is or whatever. We no idea how to say, but yeah, they should be there. And that's our goal today, really. Just make sure they exist and how we utilize them to help diagnose concerns and stuff. Right?
Absolutely.
Yeah.
So Tim Rivers, thanks. Great class.
Thanks, Ken. Thanks for being here, man.
Thanks for being here. And as Justin said, we have training centers all across the country. So if you had a technician, no matter what equipment that you have, obviously they're going to learn some tips and tricks and things with Hunter equipment, but there is a value to that, even if they're using a competitive piece of equipment, to go into one of those classes and just learning more about the angles. So if you have somebody that is that's new to the industry that you want to get up to speed, we have a level 1 course that's a 3-day course that really deep dives into those standard numbers and gets into how do I do an alignment. And then a level 2 that is really that diagnostic, modified vehicle kind of things. And then our level 3 is focused a lot that's where we suggest collision centers to go and that sort of thing, where it's into those advanced angles and identifying the bent components, damaged components, and more complex alignment situations that they may run into. And it's 2 days of not only some book time and classroom time, but also a lot of hands-on in the shop actually doing it. So we know that technicians usually are less absorb a little less from the lecture and classroom time, and more from that hands-on time. And it's a great opportunity for them to kind of collaborate with each other about things that they've each seen.
Yep.
So thank you for the opportunity, Ron. And with that, I guess we'll sign off for this Saturday in this year's 2026 PAVE meeting.
Let them know about Hunter LMS,
Oh,
please.
yes, and if you wanted to go a little bit in depth, just individually, we do have on hunter.com, they can go to Hunter University. We're jumping through some screens here.
It shows the Zoom
meeting. Go
meeting.
to the Hunter website, hunter.com, go to the LMS system, which are our learning management system. Anybody, no matter what brand of equipment they have, no matter where they are in the industry, can go in there, create a user ID and password, and there's about 15 or 18 online classes going through that. There is even some equipment certifications So if you do have some of our equipment and you got a new person that comes in, if it's a tire changer or a balancer or alignment equipment, they can actually go in and do a certification class where they'll do some classwork, answer some questions, and then get a checklist at the end of it and either contact, myself, Justin, the local field team, or they can just video themselves doing that check sheet and submit it into Hunter, and then they'll get a certificate to say that they were certified for that piece of equipment as well. So a lot of great tools in the LMS system that everybody can take advantage of, and I would really encourage that as an opportunity.
Yep, Hunter University, get to it by going to hunter.com and look for the training tab up at the top. Follow it on Hunter University, create your own learning profile, and get in there and get some great free resources for you. Thanks, everybody.
Thank you very much. Thank you.
Thank you. Have a good night.
Bye.
See you.
Bye-bye.
I want to apologize.
You still there?
I've muted you now, but now you're back.
Ron, are you still there?
We're back.
Yeah, you're the only one.